Good evening, all. I welcome you all on the behalf of StudyIQ English Discourse. My name is Pritesh Maturkar. I will be your primary faculty for this wonderful sessions which are beginning from today. The sessions are titled Geography Through Maps, and in this journey, I will be covering up your basic part of geography. Apart from this, I will also be covering with you all some very basic important tidbits of geography from GS perspective per se. And we all are starting a very fantastic journey from today onwards. And I hope and I sincerely pray that you all will appreciate this journey with me. And in due course of time, you all will be enlightened with this wonderful discipline that is geography. And also, I genuinely want that each and every one of you should qualify civil services examination in the very first go round itself. And apart from that, I also be willing that you all cover this discipline with me wonderfully. And in due course of time, I will be taking you on a world tour. Okay, I have traveled more than 46 countries myself. So you have a very good guide present in front of you. So this guide will help you in understanding geography. This guide will help you in understanding the tidbits of geography as a discipline. So before I begin, I will just like to uh, say few words to you all, and that words are that never fall in love with geography. Like geography, but never fall in love with geography. Why so? Because if you start liking geography and if you eventually fall in love with geography, so you will end up teaching geography like me. Okay. I have not yet written the board of my name on the board yet, but in due course of time, I will do that. So please don't make the mistake that you fall in love with geography. Like geography, just don't fall in love. Otherwise, it will become very difficult for you all to focus on other disciplines per se. Okay. So I'm writing my name on the board. My name is Pritesh Maturkar. I have been coaching in different institutes throughout India. I have coached in the Mecca of UPSC, that is ORN. I have been with different faculties. I am also an optional faculty of geography. So geography is kind of liking of me. It is also love of me, and I have myself dedicated my life to studying geography and now on. So I just wish that you all get on with me wonderfully, and I sincerely hope that you all will cope up with me in due course of time, because I will be starting with the very basics of this discipline, and eventually we will start moving ahead with the little bit more advanced concepts. And in this course duration, you all will be enlightened from the prelims perspective, from the mains perspective, as well as something with regard from the interview perspective. So we will all be dealing with the concept slowly, slowly, gradually, gradually. Okay. Before I begin with this discipline, first of all, I would like to highlight three to four very important issues. Okay. As to why this thing has been started on the behalf of Study IQ. Okay. So it is increasingly evident from past 5 to 6 years that UPSC is now no more focusing only on the conventional tidbits of geography. Rather, you are having questions from geography which not only come from the conventional part, but you have the current affairs part too, and you have an interlinkage between conventional and current, and that interlinkage is based on locational analysis. Okay, so if I just summarize for you some of the questions. So, very beautiful question just came 2 years back, that how do the local mountains, or how do the local topography of mountains affect the local climate? Another question was that how the melting of Arctic is different from Antarctic. So that question brought a very big smile on my face. Why so? Because such questions require in-depth analysis. Such questions require you to understand how the melting of Arctic is different from Arctic, in the sense that Arctic is basically a frozen sea surrounded by land, whereas Antarctic is a frozen land surrounded by sea. So the series which I've been beginning from today is basically focused on this aspect of UPSC civil services examination, wherein you have the amalgamation of conventional and current and interlinking with the locational thing. So this is the first thing why this series has been started. Second important thing why this series has been started, because often the aspirants, they do understand the conventional tidbits, but when it comes to locational interlinkage, their spatial and temporal skills are missing. Okay, so I will be exclusively dealing with those skills in this sessions, wherein I will be making you comfortable with maps. I'll be comfortable making you with the general geographical outline of the planet that we all live on, and that is the Earth. Okay, and the third and the most important thing, I will make you understand, I will help you grasp the concepts, and I will help you in understanding how you can use maps, how you can use your locational knowledge in answers. Because ultimately, what is our ultimate aim? That you all should score way better marks than your competitors in mains examination and of course in prelims. So these three or four things need to be kept in mind, that as to why we have started this series with you all. Okay. So I'm again reiterating, my name is Pritesh Maturkar. Okay. Any current affairs, any content which I'll be discussing in this class, and any content I feel that is important, you can just do a global search on Telegram. You can just search for the channel called as Geography by Pritesh Sir. Geography by Pritesh Sir. Okay. And you can also search by a short form global search. It is geography underscore PM. Okay. So these three things you can search on the Telegram for the current affairs material as well as for the issues which I feel are important. I'm again reiterating geography by Pritesh sir, or you can do a sharing linkage by geography underscore PM. Okay. So these two things will help you in connecting with me. And in due course of time, I'll be sharing some very interesting content, and I will also be highlighting some of the important issues that are pegging today's geography, world's geography. Okay. So before I move on, I would like to make few things clear with everyone. Okay. In the initial lectures, you all will be wondering that why I'm teaching geography from such a basic level. The thing is that geography is a conceptual discipline. It's an interconnected discipline. So mastering a discipline requires first understanding the basics of it. Okay. So the first few lectures, roughly 5 to 7 lectures from today onwards, or from let's say tomorrow onwards, we will be dealing with some very basic concepts of geography. Slowly, I will be increasing the level, and then I will be introducing with you maps, and we will do a global interlinkage. Okay. So just bear with me. That is my first request, and my sincere request with everyone. Second thing, I want that any one of you who listens to this lecture live or sees this lecture after this stream has been ended, please have a pen and copy with you. Whatever I'll be writing on the screen, you will all should jot down the points. Okay. I am a tad old school faculty, so I prefer writing on the board, and I prefer using my marker as my chalk. So this is my chalk and that is my board. Times have changed, everything has become digital. So that's the course of evolution per se. That's what I can say. But please, everyone, have a pen and copy with you. Okay. And the third thing, and I guess this is very important, once you start this journey with me, please end this journey with me only. Don't leave these lectures in the middle. Okay. Because this will be a sessions which are in a continued format. So if you are seeing lecture A and then you are directly jumping to lecture number L, that won't help you, because I will be dealing with the concept slowly and gradually. So as per your convenience, as per your time scale, please follow these lectures with utmost care. Okay. Uh, any difficulties, any queries, you can reach out to me on Telegram. I will be available over there for uh, answering your queries. So you can just do my search by me by my name, Pritesh Maturkar, or of the two channels, you can just open them up and ask me if you have any difficulties. Okay. So I welcome you all formally to this very special journey with me. These I'm not calling as lectures. This I'm calling a journey, because today is your first day in this journey, and you are starting as a very small apprentice level. We have to reach to the mastery level, pro level, and from there we have to go towards the excellency level. Okay, so welcome all. And before I begin, I will like to highlight three or four more important parameters with regards to this journey. Okay, so the first thing in this sessions, what will be the coverage? What will be the coverage, and what can be your reference material? What can be the reference material? So my coverage in this particular sessions will be limited to 11th NCRTs. 11th NCRTs. Okay, both the world physical environment, okay, and India physical setting. Okay, so both of the 11th NCRTs, primarily the physical geography. My coverage will be limited to GC Leong. Okay, GC Leong. Okay, especially the second part, especially the second part or the second half of GC Leon. Okay, and third, I will be primarily focusing on current affairs too. Okay, current affairs too. But mind you, this current affairs will require understanding of some higher level concepts. So, those of you who are attempting this year, or those of you who have done your GS part beforehand attending this lecture, so you can go with the advanced level of current affairs, or otherwise, I will be just sharing some of the links of the current affairs on the channel. So, you can follow that links and you can just move ahead. So my coverage will be in this sessions will be limited to this three. Okay, and all of these three things, okay, I will be teaching through maps. I will be teaching through maps. Hence the name of the series is Geography Through Maps. Okay, maps I will be using exclusively for most of the discussion, and maps will be my sole criteria for explaining you some of the more recent geophysical phenomenon that are happening on Earth per se. Okay, so this is the coverage. Okay, now second thing, what is expected from you all? Okay, what is expected from you all, or what this series aims to achieve in all of you. Okay, so what is expected, that whatever has been taught, number one, whatever has been taught, you have to revise. You have to revise. Okay, you have to make concise notes. Okay, without revision, without note making, civil services is a dead end. Okay, so revision and notes are very important. So whatever is being taught in any day session, please see again the lecture. If you are not comfortable with my live discourse, stop, pause, play, rewind, whatever you do, but make sure that you are again revising and you are jotting down the important points. Okay. Second, what is expected from you all is that you maintain a copy. Okay, you maintain a copy slash worksheet. You maintain a copy slash worksheet. Okay, so worksheet slash copy from what point of view? Okay, so this worksheet or copy should be from two ends, should be from 2 points of view. Okay, number one, locations. Okay, locations are going to be of primary significance in this session. So locations, and number two, okay, interlinkage. Okay, number two, interlinkage. I will highlight you how you should make notes with regards to this in due course of time, but location and interlinkage, these two things you should especially focus on in this sessions. Okay, and the third thing that is expected from you all, okay, is practice. Practice of what? Of questions, okay, from mains end, okay, and also MCQs from prelims end, okay. So please make sure that you are also doing this. Okay, in due course of time I will be giving you some MCQ objectives. I'll also be giving you some assignments as homework, so you can post those answers, you can post those summaries that you have made on the group itself. I can give you some good evaluations with regards to that, and eventually we will also try to include very good coverage of previous year's questions too, and we will have some exclusive topics, exclusive sessions with regards to what questions can UPSC ask in this discipline. Okay, so that will be a very high level discussion, but I think that it will give you immense joy that we are predicting what questions can come in UPSC. And believe me, trust me, okay, experience of having more than 8+ years, I have taught optionals. So if you go by my logic, if you go by my knowledge, so we can predict roughly 50% questions in prelims as well as mains. Okay, so we will do that. This being an open-ended session, so I'm saying live it on camera, but we can. Okay, you just have to catch the headwinds. You just have to catch the wind direction where the civil services examination is going. And in geography, it's rather easy because geography, being an interconnected discipline, being a modern day scientific discipline, so most of its questions are related to what is happening in the present year and in the past year. So it will be a wonderful journey with all of you. So this three things are expected from you. So coverage done, expected done. Okay. Now, the most important thing, what will be the flow of topics? Okay, flow. What flow I will be maintaining primarily in the sessions? Okay, so the flow will be like this. So, primarily in our first 8 to 15 sessions, okay, I will be covering with you all the basics. Okay, basics which I will be needing. Then from around 15 to, let's say, 30 or 35 lecture numbers. Okay, lecture numbers. We will analyze maps. Okay, we will do maps primarily, analyze those maps. Okay, analyze those maps. We will be focusing on current affairs. We will be focusing on current affairs. Okay, and we will also be focusing on interlinkage. Okay, this word I'm reiterating for, I guess, seventh or eighth time today, because I want you all to imbibe this word in your bloodstream. Okay, interlinkage is the key in learning geography. This word you should never forget ever. Okay, and the remaining lectures, we will be exclusively covering current affairs. We'll be exclusively covering current affairs, and we'll be exclusively doing questions. Okay, questions. So this will be my flow in the sessions. Okay, so those of you who are preparing for 2024, okay, those who are preparing for 2025, okay, this sessions, I give you my personal guarantee that this sessions will help you in scoring. These sessions will help you in scoring approximately 15 to 20 marks in prelims. And dare I say, these sessions will help you in scoring at least 200 marks in mains. At least 200 marks in mains. Uh, Guys, see, you all are preparing for civil service examination. So your immediate goal should be focused on marks. Whatever you are learning, whatever you are seeing on any platform, you should not waste your time behind the content which UPSC will never ask. Okay. So my role primarily is to give you such content which I feel which is translated in your mains and your prelims directly. Okay. So please make sure that you utilize these sessions exclusively for marks and you are not just sitting over here. Okay, let's open up and just watch some lectures. No, don't fall for this gimmick that these sessions are going to be very lucid sessions, very boring kind of sessions. No, I am a very intense faculty, and in due course of time, I will be going into the depths of analysis. So you may feel that sometimes the things are not going good, but just hold and just keep on working hard, because consistency is the key in civil service examination and in understanding geography too. Because primarily everyone feels that geography is easy, but once you start reading geography, once you start understanding geography, then the things change. Okay, so please make sure that you all bear with me till the end. Okay. Okay, so I have discussed the coverage, I have discussed the expectations from your end, and I have also discussed the flow of this. So let's formally begin the journey entitled Geography Through Maps. Okay, so now I formally welcome you all to this journey. So before I start this journey, I will be just giving you a small introduction as to what is geography. Okay, not in depth, but why this discipline has become my love, why this discipline has inspired me, that I have traveled the world and how this discipline will help you in understanding you, yourself, your lifestyle, and why this discipline is so damn important in today's times. Okay, and why climate change, global warming, sustainable development, environmentalism, greening. Okay, everything is linked to geography. Okay, your lifestyle, okay, your dietary patterns, everything is influenced by geography. So you just need to first understand that how is this happening basically. Okay, so very crude example or very crude definition of geography. Okay, so if you see the word geography, okay, first of all, don't treat geography as a subject. Okay, don't treat geography as a subject. Okay, this is not a subject, guys. Okay, this is what? This is a discipline. Okay, this is a discipline. Okay, this is a discipline. Okay, now what's the difference between subject and discipline? Okay, any discipline will have three things. Any discipline will have the scope. Okay, what is the scope of discipline? Any discipline will have some context. Okay, and any discipline will have some methods, and it will have some tools which you have to master in due course of time. Okay, so we'll be focusing on scope, we will be focusing on context, and the methods and the tools in geography are nothing but maps. So, what's my goal with you all? First of all, I have to make you comfortable with the scope of geography. Second, I have to make you comfortable with the context of geography. And lastly, I will have to make you comfortable with the methodologies and tools which are being utilized in geography. And the most important method and the tool in geography is going to be maps. So if you just follow these lectures, you will all become geographers. Okay. So that should be your ultimate aim of this session. That okay, sir, we are all becoming geographers with you. Okay. So please treat geography from a discipline perspective, not from a subject perspective, because in subject there is only content. Okay, there are no scope, there are no methods, no techniques, but we have to focus on that primarily. Okay, so geography, if I tell you like what is geography basically, like what a discipline of geography is, and how that discipline is translated today, how that discipline is functioning in the 21st century. So you should all first be comfortable with the word geography. Okay. So if I cut the word geography, it is given in two formats. Okay. It is the first word is geoid, and the second word graphy, it translates to graphene. Okay. Graphene. Okay. The word geography was coined in 6th century BCE. Okay, by a Greek scholar, by a Greek scholar called as Eratosthenes, called as Eratosthenes. Okay, so according to him, geography or geoid slash graphene is nothing but the description of geoid. Graphene translates to description. Okay, and geoid is basically the shape of Earth. Okay. So what is geography basically? Geography is nothing but the description of Earth per se. So this was the first crude understanding of geography in the late 6th century BCE by the Greek scholars, because Greeks were some of the pioneering people in establishing geography as a discipline. So the word geography comes from geoid and graphene. Okay. So the shape of Earth is basically what you are going to study eventually in this session. Okay, the shape of Earth, the orientation of Earth, the tilt of Earth. If you understand these three, four parameters, your entire geography is taken care of. So please make sure that you never go outside this definition. That what is geography? Basically, geography is nothing but description of Earth per se. Okay, there was some modification in this definition. There was some modification understanding of geography. Why? Because your life and my life. Okay, your life and you and me existing on this planet Earth. Okay, you and me are primarily concerned with what? With the yours and mine interaction with the environment. And where this interaction is happening, is this interaction happening in the uppermost reaches of Earth or in the lowermost reaches of Earth? Dare I say, is your interaction happening with the outer space? Is your interaction happening with the outermost layer of atmosphere? No. Is your interaction happening with the deepest layer of Earth core? No. So your and my interaction with the Earth is happening where? Primarily on the surface of Earth. Okay. So a very crude, or rather the most acceptable definition of geography was given in the years 1940, and there I say 1942, by the American School of Geography. And the most acceptable definition of geography is that geography is the study of surface of Earth. Okay, is the study of surface of Earth as as the home of man, as the home of man. Why? Because your and my interaction will be primarily be depending on the surface interactions which we all make with the environment. Okay. So you all guys should be focusing on what per se, if you want to study geography, how you are interacting with your environment. That's it. Okay, interacting means what? How your lifestyle is altering the environment, how the outside environment is altering your lifestyle, your age of mass consumption, how it is changing the outside ecology. That are the things which will be dealing primarily in geography. Okay, so geography per se, you should be primarily dealing with the surface of Earth because we have not yet reached to the innermost layer of Earth, and our interaction with the atmosphere is merely around 100 kilometers maximum. Outside that, we are having space. Okay, outer space beyond 800,000 kilometers, which is of insignificance to us. Okay, so geography is primarily the study of surface of Earth as the home of man. Okay, even if I transcend to even more crude understanding of geography, so your interaction with the environment, your interaction with the Earth's surface, I can chalk out in three spheres. Okay. So if I'm chalking out the three spheres for you all, okay. So the first sphere, the second sphere, and the third sphere. Okay. So if I'm chalking out these three spheres for you all, okay. So the surface which you all sit on, the surface which you're all sitting today and listening to me on YouTube, seeing me on YouTube, dare I say, okay. I hope that none of you are only listening, but you're also watching. So the surface on which you are sitting, I can call this sphere as lithosphere. Okay. The surface on which we live, the surface on which we practice cultivation of land, agriculture. Okay, you and me fulfill our energy needs by agriculture, by doing farming. The sphere through which we all breathe. Okay, we have the biological processes of respiration and photosynthesis. So that sphere we call it as atmosphere. That sphere we call it as atmosphere. And the third sphere, and the third sphere, I've deliberately drawn this sphere as big because Earth is basically a blue planet. If you see Earth from the outer space, you will see Earth as a blue dot. Why? Because 75% of Earth's surface is basically oceanic waters. So the third sphere that you have is the hydrosphere. Okay, hydrosphere. And you and me, we all sit at the confluence of these three. And the confluence of these three, this is called as what? This is called as biosphere. Okay, I'm deliberately writing it in green. You and me, we deliberately, okay, I guess green is not visible, so I'm rubbing it. Okay. So you and me, we all primarily reside in the living space where you and me interact with the environment. So the third sphere is called as biosphere. Okay. So your understanding of geography should be limited to this sphere, but you understanding this, the confluence of these three spheres, which is biosphere. So you do need to understand lithosphere, you do need to understand atmosphere, and you do need to understand the hydrosphere. Okay, so the amalgamation of these three spheres will help you in understanding your interlinkage with the environment. And for doing this, I will be primarily using maps. So see how beautiful this journey is going to be, wherein I will be using maps for what? For making you understand your relationship with the environment, for making you understand the sphere which you all interact with the environment, which is the biosphere. Okay. So just make sure that your definition of geography is rock solid. Okay. So in geography per se, we will be focusing on three spheres, the confluence of these three spheres. So geography as a discipline, geography as a modern day scientific discipline is basically grouped into two parts. Okay. Okay. You have the first division as physical geography, and you have the another division that is human geography. Okay. Okay, human geography. Okay. In crude man's understanding, the physical geography is basically the three spheres which I highlighted to you just seconds before, and human geography is nothing but the confluence of these three spheres, that is biosphere. That is biosphere. Okay. You also have some things like economic geography. You have something called as diplomacy. You all have something like societal geography. So all of these are offshoots of geography. But geography as a discipline, you should focus on these two aspects, physical geography and human geography. So my aim with every one of you is that I will be making you extremely comfortable with understanding the interlinkage between the physical geography and the human geography through maps. Okay. So we will be understanding the interlinkage between the physical aspects of Earth and with the aspects wherein you all interact with the Earth via maps. So this maps will be my bridge because maps are nothing but the tools of geography. So using maps, I will be bridging the gap between these two aspects of geography. Okay. So I hope that this definition is clear to you all. The scope of geography is clear to you all, and how we are going to proceed with regards to geography. Okay. So now let's begin with something with regards to the discussion of Earth, because the planet Earth is where you all live. We, including me, we all live. Not you, but me too. Okay. So first we need to understand the shape of Earth. First we need to understand what is Earth and how the Earth is positioned in the universe, so that we start understanding the different geophysical phenomenon on Earth. Okay. So if I ask you some tidbits, or if I point out some of the important tidbits of Earth. Okay, so Earth, basically it's a blue planet. It's a blue planet. Why it's a blue planet? Because 75% of Earth's surface is covered by water. Okay, covered by water. Okay, Earth is one of the four is one of the four terrestrial planets terrestrial planets of the solar system. Okay. Terrestrial planets means what? Okay. That Earth has a land surface. Earth has a land surface slash Earth has a rocky terrain. So you have Mercury, you have Venus, you have Earth, and you have Mars. These four are the terrestrial planets of solar system, and Earth is one of the four terrestrial planets of the solar system. Okay. The third thing, Earth basically is the densest planet. Earth is the densest planet of the solar system. Okay. Densest planet in the sense the specific density of Earth is between 5 to 5.5. Okay. So these are some of the important tidbits with regards to planet Earth, which you all should remember, which you all should never forget. Okay, they should be imbibed in your bloodstream per se. So Earth being a blue planet, 75% of Earth's surface is water. One of the four terrestrial planets of the solar system, wherein you have rocky terrain or a land surface to thrive on. And lastly, Earth is the densest planet of the solar system. And mind you, Earth is the only planet, Earth is the only planet yet discovered. I'm writing this in very bold letters, yet discovered, okay, where you find water, where you find water in all three forms, in all three forms. Okay, so you have water as ice, you have water as liquid water, and you have water as gaseous vapor. You have water as gaseous vapor. Okay, no other planet that we know as of today has water in all the three forms. Okay, so Earth is a very special planet. Okay, it has taken billions of years of evolution for the earth to make it habitable for each one of us. So we should thank the universe for our existence, because nowhere in the universe you find arrangement like this yet. Okay, we have not yet discovered, but in due course of time we do tend to discover, because it's human brain, the human ingenuity or the human curiosity which is pushing the limits of the discoveries. And in the last year only we launched the most ambitious project, the James Webb Telescope, wherein now we are having a working understanding of the beginning of the universe per se, like the Big Bang theory. Okay, so these are some important tidbits with regards to Earth. Now let us talk something with regards to the shape of Earth per se. Okay, the shape of Earth, how its shape is tilted, and how basically that affects your life on Earth per se. Okay, so if I'm drawing two shapes on the board, okay, this is shape number one, and this is shape number two. Okay, so this is shape number one, and this is shape number two. Okay, so if you see shape number one, it is perfectly circular. Shape number two is rather spherical, and it is bulging in the center. It is bulging. It is bulging in the center. Okay, and it is flattening at the poles. And it is flattening. And it is flattening at poles or at the extremities. Okay, so out of these two, which do you think is the shape of Earth? Okay, the answer is shape number two. Okay, Earth is not circular. Earth is not like a ball. Okay, Earth is spherical in shape, but the spherical shape of Earth is not perfectly sphere. It is rather bulging at the equator, and it is flattening at the poles per se. Okay, so because of this, okay, gravity tends to vary on Earth. Okay, with the distance from the center of Earth, gravity tends to vary, and this bulging and this flattening shape is responsible for some of the very prudent geophysical phenomenon on Earth, which I will be highlighting you in due course of time. Okay. So please make sure that you are comfortable with this aspect, that the Earth is spherical, it is bulging in the center, and it is flattening at the poles. Earth is not circular at all. Okay. Now, if I move the discussions ahead with you all, so the Earth being spherical, the Earth being bulging in the center and flattening at the poles per se, like this. Okay. Is the Earth's axis straight? The answer is no. The Earth's axis is not straight. Okay. The Earth's axis is not like this. Okay. The Earth's axis is not like this. It's not a straight line per se. Rather, the Earth's axis is tilted. Rather, the Earth's axis is tilted like this. Okay. Okay. Earth is not in a straight line axis, it is in a tilt line axis. And the tilt of this axis is around 23 and half degrees. Okay. And this axis points to the North Star. And this axis points to the North Star. Okay. And mind you, this tilt is not constant. Okay, this tilt varies. Okay, in due course of time, I'll be highlighting you how this tilt varies. This tilt is not constant. It does vary in around 40 to 50,000 years cycle, and Earth's tilt can move between 20 degree to 25 degrees. Okay, so but for your lifespan, for generations to come, you can consider the tilt of Earth as 23 and half degrees. So mind you, the Earth's sphere is not in a straight line axis, it is in a tilt line axis. So now, if I'm drawing the exact shape and tilt of Earth, it is somewhat like this. Okay, so this is the shape of Earth, and this is the tilt of Earth. And this is the tilt of Earth. So the Earth is oriented like this. Okay. Now, because of this, what happens? Because of this shape and because of this tilt, you have what? You have variations in the insolation received from the sun. Okay. I'm moving to the last part discussions of today's lecture. So just bear with me for a few moments. Okay. So how this tilt affects the insolation received on Earth, or how this tilt is basically affecting you and me, we are residing on the Earth. Okay. So if I just move discussions a little bit ahead. Okay. So for our sake of understanding, for our sake of um, understanding how our life on Earth varies with regards to different places on Earth. So we have divided Earth into series of latitudes. Rather, there's a parallels of latitudes and parallels of longitude. Okay. So there was a World Meridian Conference in the late 1880s. In that, it was decided that they will divide the Earth into parallels of latitude and parallels of longitude. So the parallels of latitude were the parallels of latitude were marked from 0 degree to 90 degrees north and south, and the parallels of longitude were marked from 0 degree to 180 degree east and west. Okay, so basically on Earth we do have four spheres. We have the northern hemisphere, we have the southern hemisphere, we have the eastern hemisphere, and we have the western hemisphere. Okay, the north south divide, the line dividing the north and south sphere, it was called as the equator. It was called as the equator, and line dividing the east and west, it was called as the prime meridian. The prime meridian. The prime meridian, it basically passes through Greenwich in London. It basically passes through Greenwich in London. Okay. So let's now just focus on the latitude aspect for today. So for you to understanding how the insolation received on Earth varies with respect to the Sun. So we will just paint a picture as to how the intensity received on Earth will vary from equator towards the poles per se. Okay, so let's move to that discussion. I'm just reiterating whatever we have discussed up till now. The Earth's shape is not spherical, sorry, it's not circular, it's rather spherical. It is bulging at the center and it is flattening at the poles. The Earth's axis is not straight, it is tilted. The tilt is around 23.5 degrees. For our understanding or for our advantage, for our convenience, we have divided the Earth into parallels of latitude and parallels of longitude. Okay, latitudes vary from 0 degree to 90 degree north and south, and the longitudes vary from 0 degree to 1 degree east and west. Okay. So the latitude which divides the global north from the global south, it is called as equator. So for our sake of understanding, I'm drawing the equator like line through the center of the earth like this, and the line is somewhat like this. So for our reference, let us consider this line as the equator. This is equator. Okay. The entire hemisphere to this, it is called as northern hemisphere. The entire hemisphere to the south, it is called as southern hemisphere. This point, it is called as 90 degree north. It is also called as the North Pole. This point, it is called as 90 degree south. 90 degree south, it is called as South Pole. Okay. So North Pole, Peary Point, South Pole, Embarrassment Point. Okay, the discoverers of North and South Pole per se. Okay, so if I just want to highlight that how sun's received will vary from equator towards the poles per se. So if I'm drawing the sun over here, okay, this is, let's just imagine that this is the sun over here. This is our sun god. The life on earth is possible because of the sun itself, because on the sun you are having nuclear fusion reaction. Because of that, electromagnetic radiation is emitted out, so we have energy received on earth, and this energy is responsible for photosynthesis. We have the biological processes of photosynthesis, and because of photosynthesis we fulfill our energy requirements. So sun is pivotal source of energy, the primary source of energy on earth per se. So if I'm drawing the energy received on earth from the sun, just focus on the board for a moment properly. So if I focus on the equator, the sun's rays, they fall perpendicularly. As we move away from equator towards the poles, as we move away from equator towards the poles, okay. So if you see this angle, okay, this is exactly 90 degree. After that, this angle, it starts to so this angle is exactly 90 degree. After that, this angle, it starts becoming slant. So let us say this is angle A, this is angle B, this is angle C, this is angle D, and this is angle E. Okay. So clearly from the diagram, it is visible that angle A is greater than angle B, is greater than angle C, is greater than angle D, and it is greater than angle E. Angle A being exactly perpendicular, whereas angle E being very slant or very acute. Okay. So what does this mean? This means that as we move away from equator towards the poles, the variation of sunlight received on Earth, it rather varies. Okay. The sun's rays have to travel a greater distance. So let's say I'm giving this distance as A, this distance as B, as distance as C, this distance as D, and this distance as E. So A is less than B is less than C is less than D is less than E. Okay, E being the highest distance. So as the sun's rays have to travel through a greater distance, this greater distance means that you will have more energy dispersion because the sun's rays will have to travel through more amount of atmosphere, and also the angle is very slant, the angle is very acute. So because of this, the intensity received from equator towards the poles, it decreases. So in general, if you are on equator, you will be getting the maximum burn through of the sun. Okay. And in the next lecture, I will be highlighting that the position of equator with respect to the sun is fixed. So on equator, anywhere throughout the year, 24/7, the sun's rays will always fall perpendicular. 24/7 roughly means 12 hours a day. The sun's rays will fall perpendicularly. As we move from equator towards the poles per se, the energy received becomes less because of the more dispersion, and this is one of the important reason in variations of season. This is one of the important reasons in the global temperature and precipitation distribution per se. Okay, so for today, just remember two or three things which I've discussed with you. I'm just quickly reiterating whatever we discussed today. Today I introduced you to a thing called as geography. What is geography basically? Geography is nothing but the description of geoid shape of Earth. Okay, graphene and geoid. It was coined by a Greek scholar, Eratosthenes, in 6th century BCE. The most acceptable definition of geography as of today is given in the 1940s by the American School of Geography. Geography is nothing but the study of surface of Earth as the home of man. Okay, because your life and my life is primarily interlinked with the interaction which we have with the outside environment. So the understanding of spheres of Earth is very important. You have the lithosphere, the surface on which you and me both sit. We have the atmosphere, wherein you and me breathe. We have the biological processes of respiration and photosynthesis. Third, the hydrosphere. Okay, majority of the Earth's life forms, majority of the Earth's surface is water, Earth being a blue planet. So, and the confluence of these three spheres is the biosphere where you and me interact. Okay, Earth, the densest planet of solar system, the only planet wherein you have water existing in all the three forms. Earth being one of the four terrestrial planets of the solar system. The shape of the Earth is not circular, the shape of the Earth is spherical. It is bulging in the center and it is flattening at the poles. Because of this, you do have variations in the gravitational force on the Earth, and this spherical shape is not oriented perfectly north south. It's not oriented perfectly 90 degrees with the vertical, it is rather tilted. The tilt is around 23 and half degrees. Okay. And this tilt is not constant. It varies between 20 degree to 25 degree. Okay. And this variation is roughly between 40,000 to 50,000 years. But for our lifespan, we can consider this tilt to be constant. Okay. I don't think anybody, including me, will be going for more than 100, 200 years. We don't know where life takes us in the era of artificial intelligence, whether we keep our mind alive for generations to come. But God knows what we have. Temporarily, we should only consider sun as the god of earth because sun being the primary source of energy on earth. So for our understanding, we have divided the earth into parallels of latitude and parallels of longitude. Okay. Uh, the global north and the global south, the global east and the global west. So the 0 degree latitude, it is called as equator. It separates the northern hemisphere from the southern hemisphere. This was done in the World Meridian Conference per se, and it was basically for our understanding of Earth as a planet, for making our life convenient so that we can travel, we can use cartographic tools, we can draw maps, and because of that only we were having stupendous innovations in the field of modern day navigation, and that are all because of that conference that today you all can enjoy a thing called as Google Maps on your phones. Okay, so if we see this diagram, the sun's energy, it falls perpendicularly on the equator. After that, the energy starts to fall at a slant angle. And as the sun's rays have to travel through a greater atmosphere while reaching the poles, the energy dissipation becomes less. So the energy received, it decreases from equator towards the poles. So you can say that equatorial regions are the one of the most hottest regions of the world, whereas poles are by and large colder than the equator. So temperature will decrease from equator towards the poles as a general trend, and because of variations in temperature, you will also have variations in the precipitation too. Okay. Yesterday, I introduced you to the concept or the discipline of geography. What is geography per se? So, geography is nothing but the study of or the description of Earth. Geography, the word geography was coined in the 6th century BC by a Greek scholar called as Eratosthenes. So, geography, if you divide this word, you have two words, you have geoid and you have graphene. Okay. So, geoid is basically the shape of Earth. The shape of Earth is not circular. The shape of Earth is somewhat spherical. It is geoid. Geoid in the sense that it is bulging in the center and it is flattening at the poles per se. Okay. So, that is the definition of geography. But the most accepted definition of geography came from the American School of Geography, wherein it is said that geography is nothing but the study of surface of Earth as the home of man. Okay, why? Because your interaction and my interaction with our outside environment is primarily related to the surface. Okay, we don't interact with the outermost edges of atmosphere, neither do we interact with the innermost core of the earth. Your and mine interaction with the earth is primarily related to the surface interactions. So that is the true nature of geography. And as you all know, I introduced you to the three spheres. You have lithosphere, the land on which you and me are all sitting today. You are listening to me, I'm delivering my lecture. You have the atmosphere, wherein we have gases like oxygen, carbon dioxide, nitrogen. Okay, we will cover these gases eventually in our lectures. So basically, the biological processes of respiration and photosynthesis, which are being made possible because of the envelope of gases that we have around the earth, termed as the atmosphere. And the third sphere, hydrosphere. Okay, roughly 75% of earth's surface is covered by water. Earth is a blue planet. If you see it in the outer space, so Earth will appear as a pale blue dot to everyone. Okay, Earth being a planet, it does not have a light source of its own. Whatever light is incident on Earth from the sun, that is reflected. So hence we don't call our Earth a star, Earth being a planet. The Earth, densest planet of the solar system, one of the four terrestrial planets of the solar system, and the only planet to have water in all the three forms. You have water as liquid, solid, and gas. Okay, so after this, we ventured into some of the higher level discussions with regards to the shape and tilt of the earth. Okay, so the shape of the earth being geoid, if I'm highlighting you the shape of the earth per se, so the shape of earth is geoid like this. Okay, so it is not circular, it is bulging at the center, it is bulging at the center, and it is flattening at the poles per se. Okay, and is the earth's axis straight? Is it perpendicular? No, the earth's axis is not straight, rather it is inclined with its orbital plane, and this inclination angle is not constant. The inclination angle varies, okay, between 40,000 years. Okay, so right now the inclination is around 23.5 degrees or 23.4 degrees, and this angle of inclination of the earth's axis, it varies between ages. Okay, so if I'm highlighting you the angle of inclination of earth, so let's draw the diagram again. So this is the shape of earth, and if I'm highlighting you the angle of earth's inclination like this, okay, so this is the axis of the earth, this is the perpendicular axis of the earth's orbital plane. So this angle is the angle of inclination. Okay, and this angle of inclination is not constant. Okay, it is not constant, it varies. Okay, it varies between around 22.1 degree, it varies between 22.1 degrees to around 24.5 degrees. Okay, right now this angle of inclination is between 23.4 degrees to around 23.5 degrees. Okay, so this is the angle of inclination. So because of this tilt, because of this axial tilt of the earth, you have variations in the seasons, you have variation in the insolation received. So how that variations are there and how that insolations are there, that I will be discussing. And this variation is roughly between 0 to 40,000 years. Okay, so 40,000 years, the Earth's axis tends to be slightly less inclined to more inclined. Okay, right now the Earth's axis is pointing to Polaris or the North Star. Okay, and it tends to vary between Polaris and North Star to star Vega. Okay, so these are the two stars wherein the Earth's axis can point. Okay, this is how you are having the geoid shape of Earth, which is bulging at the center and flattening at the poles, and you have variations in the axis. Okay, so now if I need to highlight the insolation received on Earth per se, how does it vary? Okay, so let us consider our star of the solar system, which is the Sun. Okay, Sun is the primary source of energy on Earth, and Sun is basically responsible for all the important atmospheric telecommunications and the energy transfer on Earth per se. So if I'm drawing the Sun over here like this, so let us consider the variations in the insolation received on Earth with respect to the Sun. So, for our sake of understanding, as I told you all yesterday, that for our sake of understanding, we have divided the Earth into parallels of longitude and parallels of latitude. It was in the World Meridian Conference in the late 1880s that we decided that we will divide the Earth into parallels of latitude ranging from 0 to 90 degree north and 0 to 90 degrees south, and parallels of longitude ranging from 0 to 1 degree west and 0 to 1 degree east. Okay, so the 0 degree latitude being the equator and the 0 degree longitude being the prime meridian, which passes through Greenwich near London. So if I'm drawing the equator for everyone, so let us assume the equator is like this. Okay, I'm drawing the equator inclined because that is how the actual tilt of Earth is. And now, if I'm showcasing you the incident received from the sun, okay, so let's assume the equator like this, incident received from the sun. As we move from equator towards the poles, okay, as we move from equator towards the poles, okay, so this is 0 degree equator, this is 90 degree north, okay. So if you see this, is exactly this angle is exactly 90 degree, and as we move towards the equator, this angle becomes very slant. And the distance, let us assume this angle as A, this angle as B, this angle as C, and this angle as D. Let us assume this distance to be capital A, capital B, capital C, and capital D. See, if I highlight you the trend over here, so angle A is more than angle B, is more than angle C, is more than angle D, and the distance A is less than distance B, is less than distance C, is less than distance D. So this means what? As we travel from equator towards the poles, the distance the sun's rays have to travel through the atmosphere increases and the angle also becomes slant. So in general, from equator towards the poles, in general, from equator towards the poles, temperature will fall. Temperature will fall because of the axial tilt and because of the shape of the earth per se. Okay, so this is what we discussed up till now yesterday. So now I'm taking the discussions ahead. Now today I'll be discussing with you all how the orbit of earth affects the life on earth and why, and how the orbit is responsible for variations in the seasons, and how do seasons change from time to time, and what are the time period of the seasons per se on earth. Okay, so let us now take our discussion to higher level. Let us now focus on the orbit of earth around the sun. Okay, so let us start with some of the very basic information that we know. Okay, Is the orbit of Earth around the Sun perfectly elliptical? Is the orbit around the Sun perfectly elliptical? Perfectly elliptical? Is the orbit of Earth around the Sun perfectly circular? Perfectly circular? The answer is both of them are wrong. Okay. The orbit of Earth around the Sun is neither perfectly elliptical, it is neither perfectly circular. Okay. The orbit of Earth around the Sun almost circular, is almost circular, is almost circular, but but with but with slight but with slight eccentricity, but with slight eccentricity. What does this mean? What does this mean? Okay, but with slight eccentricity. Okay, okay. So if I am crudely explaining to you, what does this mean? That the orbit of Earth is neither perfectly circular, neither perfectly elliptical. It is almost circular, but with slight eccentricity. It means that the orbit of Earth is almost circular, but the revolution of Earth around the Sun has got slightly elliptical characteristic, and this elliptical characteristic tends to vary between 0 to 1 lakh years. So, in 100,000 years or in 1 lakh years, the Earth's orbit can become almost circular, or it can become extremely eccentric or extremely elliptical. So, if I tend to showcase you with diagram, the orbit of Earth around the Sun is somewhat like this. So I'm showcasing the orbit of Earth around the Sun as it is of today and how it tends to vary over the ages. So if I'm drawing the Sun and the orbit of Earth, so imagine this is the Sun like this. Okay. And now I'm highlighting you the orbit of Earth around the Sun. So this is the orbit of Earth around the Sun. This is our star, Sun, and the Earth revolves around the Sun in almost circular orbit but with slightly eccentric nature. Okay, eccentric means the Sun is at one of the foci of the eclipse, and this eccentricity tends to vary. This orbit can be elliptical or this orbit can become circular. So, this is the variation in the Earth's orbit around the Sun. As of today, the orbit of Earth around the Sun is in this format, wherein the Earth is completing one orbit around the Sun in approximately 365 days. So 365 days corresponds to 1 year on Earth. Okay, 1 year on Earth, and because of this slightly eccentric orbit, because of the Earth's geoidal or spherical shape, which is bulging at the center and it is flattening at the poles, and because of the axial tilt, we have different seasons and we have different variations in the seasons. So now please focus on the board properly as I tend to explain you how do seasons vary and how do the different uh, important dates on Earth vary. So, the first thing that I will be explaining to you all are the different important calendar dates in terms of geographical locations of Earth with respect to the Sun. Okay, so if I'm drawing the Earth per se for everyone, so let us consider this as position number one. I'm deliberately drawing the Earth's position on a bigger scale so that you understand it properly. These are not perfect spheres, but for our sake of understanding, I'm highlighting the Earth's position on a proper bigger scale. So let us assume that this is the axis of Earth. Okay, let us assume that this is the axis of Earth per se. So now you can see I'm marking this position as position A, I'm marking this position as position B, I'm marking this position as position number C, and I'm marking this position as position number D. Okay, the Earth's axis is tilted. Okay, the Earth's orbit around the Sun is slightly circular, it's almost circular but with slightly eccentric nature, and you have this one orbit being completed in approximately 65 days, and the shape of the orbit can vary. It can be almost elliptical, it can almost be circular, and this variation is roughly around in 1 lakh years. So in 1 lakh years, the orbit can become perfectly circular or it can become highly eccentric, with Sun being at one of the foci of the eclipse. Right now, the orbit of Earth around the Sun is in this shape. So, now if I'm considering position number A, and if this is the equator, so as you can all see, the northern hemisphere is pointing the Sun directly. So, the northern hemisphere is pointing the Sun directly, whereas the southern hemisphere is away from the Sun. The southern hemisphere is away from the Sun. So, if I'm highlighting you, position number A, position number A. So in position number A, the northern hemisphere is pointing towards the Sun, is pointing towards the Sun, is pointing towards the Sun. Okay, that is what the northern hemisphere is getting maximum amount of sunlight, maximum amount of sunlight, maximum amount of sunlight. Whereas the southern hemisphere is pointing away from the Sun, and the southern hemisphere is not getting the incident light which is there as compared to the northern hemisphere. So what does this mean basically? So if you go to this position, position number A, so position number A, the northern hemisphere will experience what? The northern hemisphere will experience summers. The northern hemisphere will experience summers, and the southern hemisphere will experience winters. The hemisphere will experience winters. And this position number A, this is called as position number A, this is called as summer solstice. This is called as summer solstice. Okay, summer solstice. And this position is normally observed each year on 20 or 21st of June. 20 or 21st of June. So if I'm writing position number A, it is called as summer solstice, and this position is normally on 20 or 21st of June per se, where the northern hemisphere is directly pointing the Sun. So southern hemisphere being away from the Sun, it will experience winters, whereas the northern hemisphere will experience summers. Okay. So now let's come down to position B. Now, if I'm considering position B for everyone, okay, so this is position number B. So if you see position number B, now the northern hemisphere is pointing away, whereas the southern hemisphere is directly pointing the Sun. Okay, so the north is pointing away. The north is pointing away, whereas the southern hemisphere is directly pointing the sun, is directly pointing the sun. So this means what? The global north will have winters, whereas the global south will have summers. Whereas the global south will have summers. And this normally happens or on 21st or 22nd of December. 21st or 22nd of December. And this is referred to as winter solstice. This is referred to as winter solstice. Okay. So if I'm highlighting you for all in the diagram, the summer solstice and the winter solstice. So position number B, it normally happens on 21st or 22nd of December, and this is called as winter solstice. Winter solstice. Okay. Why? Because the northern hemisphere is pointing away and the southern hemisphere is pointing towards the sun. So in the north we will have winters, whereas in the south we will have summers. Now you must be wondering, sir, why we are considering this as winter solstice, whereas the global south is having summer solstice. Many of you must be wondering why these names are with regards to northern hemisphere only. So if I tend to paint the picture in front of you of the earth per se, so I'm just switching my view. We will be just discussing a little bit of Earth now. So if I'm discussing the planet Earth with each and every one of you, okay. So if I open up the planet Earth, okay. If I open up the 3D representation of Earth per se, and if I tend to draw the equator on Earth, okay. So so this is how the equator passes through Earth. Okay. This is how the equator passes through Earth approximately. Okay, I'm redrawing it so that you have a working understanding. Okay, so if you see the north of the equator, so this is the north of equator and this is the south of equator. Equator corresponds to 0 degree latitude. So if you see to the north, you will see the continent of North America. You will see majority of the continent of Africa. You will see a big chunk of, not a big chunk, but a significant chunk of South America. You will see the complete Europe. You will see complete Russia. You will see Central Asia. You will see the continent of India. You will continent per se, but not continent of India, the subcontinent of India. You will see Southeast Asia, and you will also see some of the islands of the Philippines at China, Japan group. So majority of the world's land surface is concentrated in the north. Hence, majority of the acronyms of geography discipline they pertain to the global north. Hence, we refer to it as northern summers and northern winters. The idea of winter and summer solstice is based on this only. Why? Because majority of the landmass of Earth is in the northern hemisphere today. Mind you, this arrangement of continents was not the same as it was before. The arrangement of this landmass has taken place over a course of evolution of geological history. This is the present day orientation, and hence, this being the present day orientation, we refer to it as global north and global south on the basis of 0 degree equator, and maximum landmass being concentrated in the global north. So, because of this, we refer to it as summer solstice and winter solstice in relation to only the northern hemisphere and not the southern hemisphere. So I hope uh, this is being appreciated by everyone. So position number A, it is summer solstice. Position number B, it is winter solstice. Okay. Now, if you consider position C and position D, okay, position C and position D, so you can see that position C and position D, you can see that both halves of Earth, okay, both halves, both, okay, both halves of Earth are equally exposed to the sun, are equally, are equally exposed, are equally exposed in the sense of what? That the global north as well as the global south, whereas the global east and global west, it is properly exposed to the sun on these two positions. And because of that, the both the halves of the earth being equally exposed to the sun, so these two positions, position number C and position number D, they are called as equinoxes. They are called as what? They are called as equinoxes. On the equinoxes, you will have same length of day and night. So 12 hours of day and 12 hours of night on sun. Okay. So if I'm painting you the picture of this, position number C and position number D, so position number C and position number D, they are called as equinoxes. They are called as equinoxes. Okay, they are called as equinoxes. Position number C, it is called as spring. It is called as spring or vernal. Spring or vernal equinox. Whereas position number D, it is called as autumnal equinox. Autumnal equinox. Okay, so position number C, it normally happens on around 28th of March. It normally happens on 20th of March, whereas position number D, it normally happens on 23rd of September of each year. 23rd of September of each year. So these are some of the important dates of Earth, geographical dates or important calendar dates of the Earth, which you have to remember from civil services examination point of view and for understanding your life on Earth per se. Okay, so I'm quickly reiterating the important dates for every one of you. Okay, so that you don't get confused and we can move to further discussions of these particular dates. Okay. So the orbit of Earth around the Sun is almost circular, but with slightly elliptical nature. Sun being at one of the foci, and mind you, this elliptical orbit around the Sun is not perfectly elliptical, or throughout its discourse, it becomes perfectly circular, slightly less circular, even slightly less circular, it becomes extremely elliptical, then it again reverts back to perfectly circular. And this change is approximately in 1 lakh years. For our sake of understanding, for your lifespan, for my lifespan, and those who will watch these videos, you can consider this to be fixed throughout your lifespan. Okay, none of us is going to live for more than 100 to 100 years. We don't know, this being an age of AI, where AI takes us, but for our sake of understanding, we should consider the orbit like this. Okay, so the position number A, where in the northern hemisphere points the sun directly. This is called as summer solstice. Position number A. This is called as summer solstice. Okay. It every year it will happen on 20 or 21st of June, wherein the northern hemisphere will point the sun. Position number B, wherein the northern hemisphere is pointing away from the sun and the southern hemisphere is pointing directly towards the sun. This will be called as winter solstice. Okay, this will normally take place on 21st or 22nd of December each year. Position number C, it will be called as vernal equinox. Vernal equinox. Okay, it will normally happen on 20th of March, whereas position number D, it will be called as autumnal equinox. It will be called as autumnal equinox, and it will normally happen on 23rd of September. Okay, I guess everything is clear to you now, the orbit of Earth around the Sun. Now, let us move ahead with some of the other important discussions of this particular dates. So let us now focus on summer solstice, everyone. Okay. So let us now focus on summer solstice, everyone. So some of the important tidbits of summer solstice for you all. Okay. So summer solstice, if I'm considering summer solstice is regarded as number one, the longest day in northern hemisphere. The longest day in northern hemisphere. The longest day in northern hemisphere. Okay, because the northern hemisphere being directly pointing towards the sun. Okay, and now, because of the Earth's axial tilt and because of the Earth's spherical geodal shape, the poles of the Earth, the North Pole of the Earth, will receive sunlight 24 hours a day. The North Pole of the Sun will experience 24 hours a day. The sun will not set on the North Pole on the summer solstice. Hence the name summer solstice, because you will have 24 hours daylight on the northern pole. So the second important characteristic of summer solstice is that you will have 24 hours day, 24 hours day or twilight zone, 24 hours day or twilight zone beyond 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 a latitude called as called as Arctic Circle, called as Arctic Circle, beyond the latitude called as Arctic Circle, and this Arctic Circle corresponds to 66.5 degrees north. 66.5 degrees north. So if I'm drawing on this diagram, so this is called as Arctic Circle. Okay, 66.5 degrees north, wherein beyond this you will have 24 hours daylight in the southern hemisphere. So if you go to countries like Norway, Sweden, Denmark, so there you will have almost 24 hours daylight on 21st of June. Okay, hence the word summer solstice. Okay, the third important characteristic of this date is that the position of sun with respect to the northern hemisphere, or the the latitude on which the sun's rays fall directly perpendicular, that latitude is around 23.5 degrees north. Now what do you mean by this? Please understand this very carefully. What do you mean by this, where the sun's rays will fall perpendicularly? Okay, so I'm drawing the shape of earth again. So this is our earth. This is our sun. Okay. This is the actual tilt of Earth. This is our equator. So if we consider the previous diagram, this particular diagram, so now you can see in this diagram that the sun's rays do tend to fall perpendicularly not only on the equator but on a line on a latitude like this. Okay, so here also the sun's rays will start perpendicularly. Why? Because with respect to the earth, the sun has migrated somewhat up. I'm again reiterating, with respect to the earth's position is over here, whereas the sun has slightly migrated towards the north. Mind you, the sun's position is fixed. Sun is not changing its position. Whose position is changing? Earth's position is changing. So if I'm seeing from this perspective, the sun has slightly migrated northwards. So this northward migration will also tend to push the sun's rays insolation received on Earth, and the latitude on which where the sun's rays will fall perpendicularly, or the maximum latitude on which the sun's rays will fall perpendicularly, will even increase from equator towards the north. And on summer solstice or on 21st of June, sun's rays will also fall perpendicularly on latitude which is given by 23.5 degrees north. And this latitude is called as Tropic of Cancer. So if I'm drawing 23.5 degrees north for each and every one of you, so this will be the latitude wherein the sun's rays will also fall perpendicularly on 21st of June. So if I'm considering this latitude, if you see this, consider this part, consider this part, okay, consider this, and finally consider this. Okay, so this is our Tropic of Cancer, which is denoted by 23.5 degrees north. This is our 0 degree equator. So as you can see in the diagram, the sun's rays are also falling perfectly perpendicular. The sun's rays are also falling perfectly perpendicular on Tropic of Cancer. And the Tropic of Cancer is denoted as by that latitude wherein the sun's declination angle, wherein the sun's rays fall perpendicularly on 21st of June. So, what does the Tropic of Cancer mean for everyone? Okay, what does the Tropic of Cancer mean? Okay, Tropic of Cancer mean? The definition of Tropic of Cancer. So, Tropic of Cancer is that latitude. Tropic of Cancer, I'm reiterating, Tropic of Cancer is that latitude wherein the sun's rays fall perpendicular, wherein the sun's rays fall perpendicular to the maximum extent, to the max extent, to the max extent in the sense that beyond this, beyond this, beyond this, the sun's rays will become slant. Beyond this, the sun's rays will become slant. So see this angle and see this angle. So the Tropic of Cancer will denote that latitude in the northern hemisphere wherein the sun's rays will fall perpendicularly to the max extent. Beyond that, the sun's rays will never fall perpendicular on the earth. And mind you, when this will happen only on summer solstice. This will only happen on summer solstice, that is 21st of June each year. And why this is so? Okay, very crude understanding, because on 21st of June, if you see the orbit of Earth with regards to Sun, so this position, the Sun has slightly migrated northwards with respect to the Earth. Okay, because of this inclination of this orbit. Okay, and the north hemisphere being pointing directly towards the sun per se. Okay, so very crude understanding. So the Tropic of Cancer will mark the furthermost extent wherein the sun's rays will fall perpendicularly. Above that, on any of the latitude, the sun's rays will fall at a inclined angle or at an acute angle, or the sun's rays will become slant on the earth. So in general, the Tropic of Cancer will denote the maximum extent on which the sun's rays will fall perpendicularly. So I hope this is comfortable. Everyone is appreciating this, and similar thing will happen in the southern hemisphere in the winter solstices. So if I'm trying to paint you the southern hemisphere in the winter solstice, or uh, in the position wherein the southern hemisphere is pointing towards the sun. So now let us draw that diagram too. So I'm so this is the geodal shape of Earth. This is our sun over here. This is the Earth's axis. So if you see, I'm drawing this position of Earth now, position number B. Okay, this was our position number A, the summer solstice. Now I'm drawing position number B, the winter solstice. So what is happening over here? So let us also draw the equator. So this is our 0 degree equator. This is our Tropic of Cancer. Now what is happening? The sun's rays are falling almost perpendicularly on the equator, whereas now the southern hemisphere now pointing directly towards the sun. So the sun's rays will also fall perpendicularly on the southern hemisphere to a particular extent. So as I told you, like likewise in the northern hemisphere, the Tropic of Cancer will denote the maximum extent till which the sun's rays will fall perpendicularly. Similarly, the Tropic of Capricorn will denote that latitude in the southern hemisphere wherein the sun's rays will fall perpendicularly. So if I'm showcasing you the Tropic of Capricorn, so this is Tropic of Capricorn. Okay, the Tropic of Capricorn is denoted by 23.5 degrees south. Okay, and if I'm showcasing you the sun's rays, so this is the equator wherein the sun's rays are falling perpendicularly. Also on the Tropic of Capricorn, the sun's rays will fall perpendicularly. Beyond Tropic of Capricorn, the sun's rays will start falling at an inclined angle. So see, this is perpendicular, this is perpendicular. Beyond this, the angle, my bad. This is perpendicular, this is perpendicular. This angle is now becoming slant per se. So what will the Tropic of Capricorn denote? What will be the Tropic of Capricorn denote? The Tropic of Capricorn will denote that latitude in the southern hemisphere where sun's rays will fall perpendicularly on winter solstice. And beyond this, the sun's rays will start becoming slant. Beyond this, the sun's rays will becoming slant. Okay. So as we move away from the tropics towards the equator, the sun's rays will start becoming even more slant. So in general, if I am showcasing you with regards to the orientation, so just see the southern hemisphere in this diagram. With regards to the northern hemisphere, the sun has migrated somewhere down in the southern hemisphere, whereas the northern hemisphere has slightly moved up. Mind you guys, these are very crude words, okay? In actuality, nothing is going down and up. This is all apparent migration. There is not actual migration. Why this is happening? Because of the eccentric nature of the Earth's orbit and the angle of Earth's orbital plane with respect to the sun's orbital plane. So imagine the sun is over here, the sun is over here, the earth is over here. So with regards to earth, the sun has slightly migrated northwards. If you are coming over here with regards to the earth, the sun has slightly migrated in the southwards. So migration means what? Which hemisphere is receiving the brunt of sunlight? So on summer solstice, the northern hemisphere will receive the brunt, and the Tropic of Cancer will mark that latitude wherein you will have maximum received, wherein the sun's rays will fall perpendicularly. Beyond that, the sun's rays will never fall perpendicularly. Whereas in the winters, whereas in the winter solstice, the Tropic of Capricorn will be that latitude wherein the sun's rays fall perpendicularly, and beyond this, the sun's rays they start falling at a slant angle. So, what will the Tropic of Cancer and Tropic of Capricorn denote? The Tropic of Cancer and Tropic of Capricorn will denote the maximum extent to which the sun can migrate in the northern hemisphere and the sun can migrate in the southern hemisphere. If I'm showcasing you this on with regards to the mapping, okay, so let's open up the map of Earth. Okay, so this I'm showcasing the Tropic of Cancer. Okay, this this being the Tropic of Capricorn, cutting Australia directly in half person. So if I'm writing over here, this is 0 degree equator. This is 23 and half degrees north. This is 23 and half degrees south. Okay. So what will these two tropics denote? These two tropics will denote the maximum northwards and the maximum southward migration of the sun with respect to the earth. But mind you, this migration is apparent. This migration is not actual. This is happening why? Because of the inclined nature of the earth's orbit and the inherent eccentric orbit of earth around the sun. Okay, so the sun will be on Tropic of Cancer on 21st of June. Sun will be on Tropic of Cancer on 21st of June, and Sun will be on Tropic of Cancer on 22nd or 23rd of December. Okay, so the Sun will be directly shining on this latitude on 21st of June, and Sun will be directly shining on this latitude on 23rd of December. So as the Sun is in the northern hemisphere, this part of the world will experience summers. Okay, and this part of the world will experience winters. And on 23rd of December, as the sun is over here, so on 22nd or 23rd of December, this part of the world will experience summers. Okay, so the shape of the earth. the actual tilt of the Earth, the orbit of Earth around the Sun, and because of the eccentricity, the variation in the eccentricity and the variations in the actual tilt, you have different seasons on Earth. So these are the five primary reasons for variations of seasons of Earth. So yesterday I introduced you to the thing called as the tropics. In the previous sessions, I introduced you to a thing called as equator and the shape of Earth, the tilt of the Earth. So yesterday we further aggravated our decisions towards understanding the different geographical dates on the calendar. So yesterday I introduced you to the different orbital dates of Earth. So if I'm revising quickly that for every one of you. So the orbit of Earth is not perfectly circular, it is slightly elliptical, okay, with a small eccentricity. The orbit of the Earth tends to shift from perfectly circular to perfectly extremely elliptical to slightly less circular, slightly less ecliptic, okay. And this variation is roughly between 1 lakh years. So in 1 lakh years time, the orbit of Earth will vary from being perfectly circular to perfectly elliptical and then back, okay. So if I'm drawing the orbit of Earth, which is there as of today. So let's just imagine that this is our sun. Okay, I'm drawing it using red pen. Okay, and let's assume that this is the orbit of Earth per se. Okay, so this is our sun. Okay, and the orbit of Earth around the sun as of today is like this. It's not perfectly circular, it is slightly elliptical with sun at one of its foci. Okay, so we have marked up four distinct dates in the geographical calendar yesterday. So I'm marking up the four positions again. So this is position one position, this is another position, okay, this is another position, and this one is another position, okay. And let us consider this to be the axial tilt of Earth, which is roughly 23.4 degrees as of today, and the axial tilt of Earth will vary between 22.1 to around 24.5 degrees in a lifespan of around 0 to 40,000 years. So for your lifespan particularly, you can consider the tilt of Earth to be constant, okay. So we have marked up four positions yesterday. This was position number A, this was position number B, this was position number C, and this was position number D. So if you see position number A, and if I divide the Earth into two hemispheres on the basis of equator, so in position number A, the northern hemisphere is directly pointing the sun, whereas southern hemisphere is away from the sun. So the global north is pointing towards the sun, whereas the global south is pointing away from the sun. And because of this, the position A will coincide with a thing called as summer solstice. Okay, so you will have northern summers. Position A will be called as summer solstice, and the summer solstice will appear on 20 or 21st of June each year. Okay. Whereas if you see position B, now the southern hemisphere is directly pointing the sun, whereas the northern hemisphere is pointing away from the sun. So position number B will be called as winter solstice. Okay. I already discussed yesterday why we are talking winter solstice over here, why we are not calling it summer solstice again. Why? Because majority of the Earth's landmass is concentrated in the northern hemisphere per se. So whatever these abbreviations are there, these are with respect to the northern hemisphere and not the southern hemisphere. Okay. In the southern hemisphere, you just have a tapering landmass of South America. You have little bit of Africa, you have little bit of Australia and New Zealand and some of the oceanic islands. That's it. Majority of the world's landmass is concentrated in the northern hemisphere. Okay, so these are the two important geographical calendar dates. So the summer solstice will coincide with the sun moving in the northern hemisphere. So 20 or 21st of June will mark the most extreme position of Sun in the northern hemisphere, and latitude-wise, this position is denoted by Tropic of Cancer. So on 21st of June, Sun will be directly overhead. Sun will be directly overhead on Tropic of Cancer. Whereas on winter solstice will normally appear on 21st or 22nd of December. Okay, so Sun will be directly overhead on Tropic of Capricorn. On Tropic of Capricorn. So Tropic of Cancer will be denoted by 23.5 degrees north, whereas Tropic of Capricorn will be denoted by 23.5 degrees south. So if I'm showcasing you with regards to the diagram of this, so let us say this is our Sun. Okay, let us assume this is our let us assume this is our Earth. Okay, okay, this is the actual tilt of Earth on 21st of June. Okay, and this is the actual tilt of Earth 22nd of December. This is our equator. This is our equator. So now if you consider this position now, so the sun's rays will start falling perpendicularly. They will always be perpendicular on the equator. So sun's rays, they will be always be perpendicular on the equator. Okay. So now if you consider this side, the sun's rays are also perpendicular at this latitude, and this latitude will coincide with the Tropic of Cancer. Okay. So Tropic of Cancer will now denote the maximum extent till which the sun's rays fall perpendicularly in the northern hemisphere. Hence, on Tropic of Cancer, on 21st of June, sun will be directly overhead at 12 p.m. sharp. Why? Because the sun's rays are falling perpendicularly. After this, the sun's rays will start falling at an angle. The sun's rays will start becoming slant. So mind you, the Tropic of Cancer will denote that latitude wherein the sun's rays will fall perpendicularly on 21st of June, after which the sun's rays will start falling slant. Similarly, if we consider this 22nd of December, and if we consider the sun's rays, so sun's rays now will fall perpendicularly on Earth at a latitude called as Tropic of Capricorn. We can denote the Tropic of Capricorn like this. So this angle now becomes perpendicular. Beyond this, the sun's rays will start becoming slant, and of course the sun's rays will fall perpendicularly on the equator too. Okay, the position of equator with respect to the sun is fixed every year. Okay, so this was the discussion yesterday. So the Tropic of Cancer and the Tropic of Capricorn will mark up the northernmost and the southernmost extremities wherein the sun's rays will fall perpendicularly on 21st of June, that is summer solstice, and on 22nd of December, that is winter solstice. Beyond this, the sun's rays will start falling slant. Okay, so now let us continue our discussions even further. So up till now we have discussed four latitudes, dare I say three latitudes. So I have discussed the 0 degree equator. Okay, I have discussed the two tropics, 23.5 degrees north, that is called as Tropic of Cancer. I have discussed 23.5 degrees south, that is called as Tropic of Capricorn. Okay, so now I'm moving to even further discussion. We are adding two more latitudes over here. So the two more latitudes that I'm adding as of now, they are 66.5 degrees north. This latitude is called as Arctic Circle. This latitude is called as Arctic Circle. And 66.5 degrees south. This is called as Antarctic Circle. Okay. So now what do these two latitudes denote? Okay. So if I'm discussing with regards to the orbit of Earth with regards to Sun, so now if you see position number C and position number D, if you see position number C and position number D, so in position C and position D, both of these dates, you will have equal halves of Earth being equally exposed to the Sun. So you will have 12 hours of day and you will have 12 hours of night. And these two positions, C and D, they will be called as equinoxes. Position number C will be called as vernal equinox. It will be called as vernal equinox. Whereas position number D will be called as autumnal equinox. It will be called as autumnal equinox. It will be called as autumnal equinox. So these dates are very important from the Arctic Circle and from the Antarctic Circle perspective. Why so? That I'll now care to explain you. So now, if you want to assess what do you mean by Arctic Circle and what do you mean by Antarctic Circle, so now let's open up the map of the world per se. Okay, and let us discuss with regards to the Arctic Circle and the Antarctic Circle. So we have already finished up discussing the tropics, the equator. So now I'm drawing the Arctic Circle for every one of you. Okay. So the Arctic, there was some audio in the order. Sorry for that. So this is our Arctic Circle. Now, what will this Arctic Circle denote for the world? Okay. So this Arctic Circle will denote that latitude. This Arctic Circle will denote that latitude wherein if you go above this latitude, the sun will neither set or the sun will not rise for at least 1 day in each calendar year. I'm again reiterating, if you go over here, so the Arctic latitude will denote that the Arctic latitude or the Arctic circle will denote that latitude wherein the sun will not set or the sun will not rise at least for one day in a calendar year. Now, what do you mean exactly by this? Okay, so now I'm opening up the 3D image of Earth for you all. Okay, so if I'm going over here, if you see this, this is our North Pole. Okay, so this is our North Pole, and this is our Arctic Circle, like this. Okay, this is denoted by 66.5 degrees north. Beyond this, the sun's rays will fall at an extremely slant angle. Beyond this, the sun's rays will fall very diffused. So because of this, number one, you are having very cold temperatures. So the Arctic Circle, it is also called as tree line. The Arctic Circle is also called as tree line. Okay. Why? Because beyond the Arctic Circle, you will not find any trees. You will not find any big tall trees. You will rather find very small bushes and called as mosses and lichens. Okay. Above Arctic Circle, you will not find any trees. And above Arctic Circle, you will also find the home of Santa Claus. Okay. That also, I will dare say this. Okay. Jokes apart, but you find the home of Santa Claus over there. And above this Arctic Circle, what will happen? If you go to the poles per se, the poles will have 6 months. The poles will have 6 months of darkness, 6 months of darkness, and 6 months of daylight, and 6 months daylight of daylight. Why? This is with regards to the position and the actual tilt of the earth. So if you consider this part of the world, wherein if you move towards the polar regions over here, so the sun's rays, whenever if the sun is in northern hemisphere, so the sun's rays will always be reaching the northern pole. Why? Because it is exposed to the sun. So if you go to the northern pole on 21st of June, you will have 24 hours sunlight on the northern pole. Whereas if you go to the North Pole in the winter solstice, you will have 24 hours of darkness. So 66.5 degrees north or the tree line will also denote that latitude wherein for at least one day you will have complete sun in the sky, or for at least one day you will have complete darkness. The sun will not rise above the horizon. When you will have the complete one day, you will have the complete one day on summer solstice. So the sun will just peak above the horizon, sun will remain over there, and then sun will always be there for 24 hours of day. Whereas if you go to the North Pole on the winter solstice, if you go to the North Pole on 22nd or 21st of December, the sun will not rise up above the horizon. It will rather be below the horizon, approximately 5 to 6 degrees below. Okay, it will not rise up. Why? Because of this orange, because of this alignment of the North Pole. So the North Pole is basically always, it will always be, position of the North Pole will always be like this with respect to the sun. So for 6 months you will have light, and for 6 months you will have darkness. So remember, I told you that the equinoxes days are very important. Why? Because on one equinox, the sun will permanently set over one pole, and the sun will permanently rise over the another pole. Whereas on the another equinox, the sun will set on one pole and will rise up on the another pole. So the two equinoxes, the 20th of March and 23rd of September, will denote that dates wherein the sun will either rise over the North Pole or it will set on the North Pole. Okay, so now let us move towards the discussion. So mind you, I'm again reiterating the 66.5 degrees north, the 66.5 degrees north will denote that latitude wherein you will not have any trees above. You will not have any trees above. This is also called as tree line, or it is also called as Arctic Circle. And above the Arctic Circle, you will at least have one day wherein the sun will never set, or one day when the sun will never rise up. Okay, I will write those things for you all. Just keep this in mind. Now, if we move to the southern hemisphere, okay, the southern hemisphere will again have the same thing. In the southern hemisphere, you will have the Antarctic Circle. So if I take you all to Antarctica, and if I'm drawing the Antarctic Circle for you all, which is denoted by 66 and half degrees south, 66 and half degrees south. Okay. So what will this circle again denote? This circle again denote that beyond this, you will not have trees. There will be no trees beyond this circle. Okay. There will be no trees beyond this circle. And also, beyond this line, you will have at least one day when the sun will never rise. So, when the sun will never rise, of course, during the time of winters. So, southern winters means what? Northern summers. The sun will never rise on Antarctica on 21st of June, whereas the sun will rise over Antarctica on 22nd of December, because then the northern hemisphere will enter into winters, whereas the southern hemisphere will enter into the summers. I will jot that down, everyone. I know it's a bit confusing, but it's also a bit interesting. Just imagine that you are a small penguin on the southern pole. So you are a small penguin, so you have to be in darkness for 6 months and you have to be in daylight for 6 months. Here we can't even manage 124 hours fruitfully. So just imagine how the penguins will manage 6 months of darkness and 6 months of daylight. Okay, jokes apart, so let's move ahead. So I'm writing all those points for you all now. Okay. So what does the 66 and half degrees north and 66 and half degrees south denote? Okay. So the 66 and half degrees north, or the Arctic Circle will denote that latitude where, number one, beyond which beyond which beyond which you will find no trees. Okay, their vegetation over there will be very small. You will have mosses and lichens. Okay, you will have mosses and you will have lichens over there. Basically, the area to the north of 66 and half, it is called as permafrost. It is called as permafrost. Okay. Number two. Number two. Okay. The sun will not rise or set for for at least for at least one day, that is either on 21st of June. So 21st of June you will have 24 hours daylight. You will have 24 hours daylight, and on 22nd of December you will have 24 hours of darkness. You will have 24 hours of darkness. Where? In the northern hemisphere. In the northern hemisphere. Okay. Whereas in the southern hemisphere, the conditions will be exactly opposite. In the southern hemisphere, the conditions will be exactly opposite. So in the southern hemisphere, on 21st of June, you will have 24 hours of darkness, whereas on 22nd of December, you will have 24 hours of daylight. And mind you, the rising and the setting of the sun is not like what we see on the equator, not we see on the tropical lands where you and me both reside. Okay. Here the sun rises, it reaches above our head and then sets. Whereas if you move to the poles, because of they being so far distance from the sun and the orientation of Earth with respect to the sun will just peek up from the horizon. It will just peep from the horizon. It will remain over there for 24 hours and for eternity if you are in June. Whereas if you move down south, the sun will rise up and then it will set. So hence 21st of June it is called as the day of perpetual sunlight in the northern hemisphere. So if you move to the polar regions, it will be called as the day of perpetual sunlight. And if you move to the northern pole on 22nd of December, it will be called as the day of perpetual darkness. Okay. I'm again opening you all the diagram of Earth per se, so you understand this very properly. Okay. So let's assume this is our Earth. Assume means like for now I'm just showcasing you all the Earth. Okay. Assume this is our sun. Okay. Now, okay. Let us assume this to be the axial tilt of the Earth. Okay. And let me draw the equator for everyone so that you get a bird's eye view. Okay. Let us assume that this is the equator of Earth per se. Okay. So now if I start rotating the Earth, we are considering 21st of June. Okay. I'm considering what? I'm considering 21st of June for everyone. This is 21st of June. Okay. Now see the northern hemisphere. Okay. If you see the sun's rays are always falling on the northern hemisphere. The northern hemisphere is always lit. Okay, this is the rotation of Earth per se. And this being the polar locations, the sun's rays will fall at a slant angle. It will be diffused. It will not be the same as in the case of the other latitudes. Okay, so the northern hemisphere will always be exposed. And if you consider the polar regions, the north pole will always be exposed to the sun. So on 21st of June on the north pole you will have 24 hours of daylight. Okay, it will be called as the perpetual daylight day on the northern hemisphere. whereas if we move down south Whereas if we move down south, the exact opposite thing will be happening in Antarctica. Why? Because Antarctica will be away from the sun and Antarctica will receive almost zero sunlight. Receive in the sense there will be some sunlight, but that will be extremely diffused. Okay. So Antarctica will enter into perpetual darkness on 21st of June. So northern summers, southern winters, southern summers, northern winters. Okay. So please remember this guys very, very properly. Okay. So I'm quickly reiterating for you all both of these latitudes 66.5 degrees north and 66.5 degrees south. Okay. So what do these two latitudes denote? 66.5 degrees north and south, they will denote two lines, the Arctic Circle and the Antarctic Circle. Beyond this, you will not find any trees. The vegetation will be very small. You will have small mosses and lichens. Okay. Beyond this, you will have at least one day when the sun will neither rise up or the sun will neither set. When the sun will not set, it will not set on the summer solstice. When the sun will not rise on the winter solstice. And the exactly opposite will be happening in the southern hemisphere. Now, let us connect this with the equinoxes. Okay. So remember these two equinoxes which we have discussed. Okay. So remember position number C and position number D. Okay. So position number C or the spring equinox, it happens on 28th of March each year. Whereas position number D or the autumnal equinox, it normally happens on 23rd of September. Okay. Happens on 23rd of September. So now if I'm considering 28th of March, what is happening? The northern hemisphere is now getting exposed more to the sun. So the northern hemisphere is entering into summers. So the spring equinox or the vernal equinox will coincide with that day when the northern pole will experience the first of the sun's rays for the first time after 6 months of darkness. So we will have first sunrise on the northern pole on 28th of March. Guys, this is very interesting information. Why? Just imagine that you are a polar bear and you are seeing the sun for the first time after 6 months. Okay, so the spring equinox will become very important for you as a polar bear because you are hibernating and you are now coming out from the hibernating winters and you are now experiencing the sun's rays for the very first time. So 20th of March will be the first sunrise, will be the first sunrise over the North Pole, whereas it will be the last sunset over the South Pole. The South Pole will now enter into perpetual darkness. So it will be the first sunset over North Pole and first sunrise over the North Pole and the last sunset over the Southern Pole. This will be when on 20th of March. So 20th of March you will see the sun for the first time peeping over horizon on the North Pole, whereas for the last time the sun will set below the horizon, and after that you will have 6 months of darkness on the on the Southern Pole. Okay, so very interesting information this is, but it's so it that is what Earth is. Okay, Nitish Kumar, thank you. Good evening. I hope you are enjoying this session. Okay, so let's move ahead. So this is with regards to 20th of March per se. So now just let us discuss 23rd of September too. Okay, so what will be the 23rd of September coinciding with? So if you now see 23rd of September, the Earth is moving, the northern hemisphere is moving from summers to winters. So the northern pole will be experiencing winters, whereas the southern pole will be experiencing summers. Okay, so for the first time on the southern hemisphere, the sun will peep up over the horizon on 23rd of September. So 23rd of September will be the first sunrise where on the southern pole, whereas it will be the last sunset on the northern pole on the northern pole. Okay, so beyond this the northern pole will enter into perpetual darkness for 6 months because the northern pole will now be pointing away from the sun, and the northern pole will come under the sun's rays only on the 20th of March, that is the vernal equinox. So these days becomes very very important, hence I've discussed this 4 days with you all of the geographical calendar year, because these days are very imbibed into the life of Earth per se. The seasons, okay. The summer solstice is beginning of summers in the northern hemisphere, whereas the winter solstice coincides with the beginning of winters in the northern hemisphere. So your life and my life on the Earth is closely linked with all these important dates. Okay. So if I'm quickly summarizing for you all everything that we have discussed up till now, please pay close attention to me now, everyone. So, up till now, I discussed with you the shape of Earth. It's geoidal, it's spherical, it's slightly bulging at the center and flattening at the poles. And the tilt of Earth is not straight, the tilt of Earth is slightly inclined with the vertical. The tilt right now, as of today, is around 23.4 degrees. Okay, so because of this, as we move from equator towards the poles, the sun's rays they start becoming increasingly slant, and hence, from equator towards the poles in general, the temperature decreases. Okay, if you consider the orbit of the Earth, you will have very two important dates. You will have the two solstices, the summer solstice and the winter solstice. The summer solstice and the winter solstice will coincide with the maximum northern and the southern migration of the sun with respect to Earth. Mind you, this migration is apparent, this migration is not actual. if I'm again showcasing you the diagram of the orbit of the Earth, so if you are considering this position, 21st of June, so with respect to the Earth, Sun has slightly migrated above. Above means northern. Why? Because of the inclination of the Earth's orbit with respect to the Sun. And if you are coming over here, so with respect to the northern hemisphere, Sun has slightly migrated down south. Again, see guys, this is all apparent. This is because of the angle of the orbital plane of Earth with the orbital angle of the Sun. Okay, these are all apparent motions. Okay, and these two solstices will coincide with the northernmost and the southernmost extent of the Sun with respect to the Earth. Okay, so and they will also coincide when the sun's rays will fall perpendicularly, the maximum extent till which the sun's rays will fall perpendicularly on Earth. Beyond this, the sun's rays will start increasingly becoming slant with respect to the Earth. Okay, so now if I'm showcasing this all on the Earth's map, whatever we did up till now, so let's do this. Let's finish this off so that we can move even to the higher concepts. So I'm quickly marking up all the latitudes for you all the important latitudes for you all. So the first latitude that I will be marking is the 0 degree equator. Okay. So the 0 degree equator. Okay. Then you have the two tropics. Okay, Tropic of Cancer and Tropic of Capricorn. I'm using red color for denoting the two tropics. I'm also showcasing you all the Tropic of Capricorn. Okay. So this is 0 degree. This is our equator. This is our Tropic of Cancer. Okay. 23.5 degrees north. This is our Tropic of Capricorn, 23.5 degrees south. This is our Tropic of Capricorn. Okay. What do these two tropics will denote? These two tropics will denote the maximum extent of the northernmost and the southernmost migration of the sun. This is north and this is south. And sun will be directly overhead on Tropic of Cancer on 21st of June. So this latitude corresponds with the 21st of June calendar year. On 21st of June, sun will be directly overhead on Tropic of Cancer. Beyond this, the sun's rays will all fall at an angle. So the sun's rays will become increasingly diffused above. Okay, increasingly become diffused above. Whereas the sun will be directly overhead on Tropic of Capricorn. On Tropic of Capricorn on 23rd of sorry on 22nd of December 22nd of December, and beyond this, the sun's rays will all fall at an angle which is slant, and the sun's rays will become diffused. Okay, so the northernmost and the southernmost extremities of the migration of sun with respect to the earth, and mind you, this is apparent migration, this is not actual migration. Okay, so now I'm giving you a very good tidbit. Okay, hi Suresh and Nitish, if you are listening to me, listen to me this very carefully. Those who will be listening to me in the lectures too, we celebrate festivals like Makar Sankranti, we celebrate festivals like Uttanarayan, we celebrate festivals like Pongal. Okay, so what do the festivals like Uttanarayan, Pongal, and Makar Sankranti denote? They denote the apparent migration of the sun in the northern hemisphere. They denote that sun is now finally entering into the northern hemisphere, so now we can harvest our crops. So during this festivals, we like to eat sesame seeds. Why sesame seeds? Because we have just migrated from winters and we are slowly progressing into spring, and from spring we'll be progressing into the summers. So our digestive system does not work that much fine with the changing seasons. Hence we eat sesame seeds. Hence we eat thing called as sarso ka saag and the roti which is made up of maize. All these things, they do what? They ignite our digestive fire because we are moving from winters to spring to summers. So your diet, whatever you are eating according to the seasons, is closely linked with this movement of sun between Tropic of Cancer and Tropic of Capricorn. Hence I told you that geography is a discipline which is very much linked to your diet too. Okay, so always study geography from this perspective. If you remember geography from your dietary preferences perspective, you will never forget geography. Okay, and that is how I teach to the aspirants. You will remember this very beautifully. Okay, and mind you guys, the migration of sun with the northern and the southern hemisphere is also responsible for variations in the different atmospheric wind movements too. Okay, that are some advanced little concepts. We'll come to that too. But just make sure that you are comfortable with this fact that sun will migrate between Tropic of Cancer and Tropic of Capricorn. The other two latitudes which we have discussed today, I'm now marking those latitudes for you too. Okay. So the other latitude that I have discussed with you all today is the Arctic Circle, okay, and the Antarctic Circle, and the Antarctic Circle. Okay. This is our Antarctic Circle. Okay. So if I'm writing these things for you all, so this is 66 and half degrees north. This is 66 and half degrees south. Okay. Beyond Arctic Circle, you will not find any trees. Okay, you will not find any trees. This region is called as permafrost. This region is called as permafrost. It is permanently frozen. And beyond this, you will have at least one day when the sun will never rise up above the horizon or the sun will never set below the horizon. So when the sun will never rise up, that will be corresponding with the winter solstice, and the sun will never set, that will be corresponding with the summer solstice. So above Arctic Circle, you will not have any daylight if you are in the winters, and above Arctic Circle you will tend to have almost more than 12 hours of daylight if you are in the summers, and exactly opposite will be happening in the Antarctic Circle. Okay, so 66 and a half degrees south, you will have at least one day when you will have 24 hours of daylight, and that will be in the southern summers. So that will be on the winter solstice, that is 22nd of December, whereas you will have 24 hours of darkness beyond the Arctic Circle on 21st of June, when the northern hemisphere will be experiencing summers, whereas the southern hemisphere will be experiencing winters. And mind you, this rising and setting of the sun is linked with the equinoxes. Okay, the 20th of March, okay, the spring equinox. So for the first time, North Pole will receive sunlight. So North Pole will experience the first sunrise after 6 months of darkness, whereas the Antarctica or Antarctic Circle will experience the last sunset. It will now go into 6 months of perpetual darkness. And exactly opposite thing will be happening on 23rd of September. 23rd of September, the North Pole will have its last sunrise, whereas the South Pole will experience its first sunrise after 6 months of darkness. Okay, so just imagine the arduous life of penguins and all those animals who reside in the poles. They have to deal with 6 months of darkness and 6 months of daylight throughout their life cycle. Okay. And mind you guys, okay, because of climate change and this interrelation of Earth with respect to the Sun, climate change is aggravating all of the ecological changes, all of the polar ice melting, and climate change is basically resulting into even more adverse consequences for the life forms over here. Already their life is so damn difficult because they have to face 6 months of daylight and 6 months of darkness. For the first time this year in the sense 2021 and 2022, you had ice-free winters in Alaska. Okay, if I'm drawing over here, so this part of the world for the first time you had ice-free winters over here. This part of Norway, this is called as Lapland. Lapland is the home of Santa Claus. Okay, so for the first time in 2021 and 2022, you had ice-free winters over here. Okay, because of climate change. And the primary occupation of the Lapland is reindeer rearing. Okay, for the people of Lapland, reindeer is the most important animal. Okay, and because of ice-free winters, reindeers basically they dug out the small mosses and lichens in the snow and they feed on them. Because of that, because of ice-free winters, the reindeer population is now increasingly becoming less. It is dwindling at rapid pace in the Lapland, and this is affecting the life of the local Eskimos and the people over there too. And guys, you will be shocked to hear this. Because of climate change, Norway, Finland, Sweden. So if I'm opening up the Earth's atlas for you all, if I'm opening the Earth for you all, okay, let's open the Earth for you all. Okay, so if I'm taking you to the countries which are to the north of the Arctic Circle, okay, so let us assume that this is our Arctic Circle. Okay, it goes like this. This is our Arctic Circle like this. Okay. So the countries of Norway, Denmark, Sweden, Finland. Okay. The Nordic countries and the Finnish countries. So for the first time, these countries are now experiencing summer temperatures which are way above 25 degrees too. Okay. You will be shocked to hear that the Russian part of the Arctic Circle, you have a city over here called as Verkhoyansk. There is a city over here called as Verkhoyansk. If I'm writing the name of the city for you all, okay. Verkhoyansk is the northernmost, most habitable or the highest habitable city anywhere in the northern polar region above the Arctic Circle. The name of the city is Verkhoyansk. Verkhoyansk. The population of the city is roughly 3 lakh 20,000, and it is the most densely populated city anywhere to the north of Arctic Circle. So last year, Verkhoyansk reached temperatures of around 37 degrees Celsius. Just imagine. I'm talking that above Arctic Circle, you won't find any trees. It is called as permafrost region. But for the first time last year, a city called as Verkhoyansk, which is the most populated city to the north of Arctic Circle. The population of the city is roughly 3,20,000. This city reached temperatures of 37 degrees Celsius. So climate change is aggravating everything which is to the north of Arctic Circle. So it is aptly said that if you want to witness what is climate change, you should go to the north of Arctic Circle. Then you will truly see what climate change is actually doing to over there. Okay, and the exactly opposite is happening in the southern hemisphere. Okay, so if you go to the southern hemisphere, if you go to Antarctica, the things are even more arduous in the southern hemisphere. Okay, so if you see Antarctica over here, okay, okay, so this is our Antarctic Circle. Okay, if you closely observe Antarctica, Antarctica is what? Antarctica is a frozen land, is a frozen land surrounded by sea. Frozen land surrounded by sea. It is a frozen land surrounded by sea. And because of climate change, okay, the waters around Antarctica are increasingly becoming warmer. Okay, there is a current, ocean current over here. Now, let's not move into that. I'm just giving you some hints. There is a continuous ocean current around Antarctica. It is called as west wind drift. And because of climate change, the ocean current is flowing with even more speed, and it is resulting into historical melting of Antarctica. So this year you had one of the biggest glaciers which came out from Antarctica. The glacier came out from this part of Antarctica. Okay, so this part of Antarctica is from where the glacier came outside, and the square foot area of the glacier was approximately 20,000 square kilometers. So the glacier of the size of New York and London, it broke out from the Antarctica. So climate change is aggravating everything to the north of the Arctic Circle and the north of the Antarctic Circle. So these four latitudes, guys, the Tropic of Cancer, the Tropic of Capricorn, the Arctic Circle, and the Antarctic Circle are very important from your prelims perspective as well as from your mains perspective for understanding the global variations in climate because of climate change and global warming. So I hope that all of these discussions are clear to you all. Okay, I'm again reiterating. My name is Pritesh Maturkar. Okay, so yesterday I introduced you to the Arctic Circle and the Antarctic Circle. The Arctic Circle is denoted by a latitude called as 66.5 degree north, whereas the Antarctic Circle is denoted by 66.5 degrees south. Okay, what do these two latitudes denote? These two latitudes denote that above these areas means from 66.5 degrees north to above, and from 66.5 degrees south to below, up to the north and south pole, up to the north and south pole, you will have no trees. Okay, you will have no trees. Okay. Number two, these will be the areas of permafrost. Okay. Permafrost. Permafrost means these areas will be permanently frozen. Okay. So basically the cryosphere of the earth, if I'm utilizing one common name for this is called as the cryosphere of the earth. Okay, so cryosphere does also include the glaciers, it does also includes the snowfall, but majority of the cryosphere of earth, dare I say 70%, will be included in this part upwards of 66.5 degree north and 66.5 degree south. Okay, the third thing which both of these latitudes will denote, these latitudes denote what? At least one day, at least one day, to the north and south of this, you will have 24 hours of daylight. On when? On summer solstice. And you will have at least 24 hours of darkness. 24 hours of darkness on what? On winter solstice. Okay. And mind you, these things will get opposite with the opposing poles. So on 21st of June, you will have 24 hours daylight on the northern pole, whereas you will have 24-hour darkness on the southern pole, whereas the exact thing will happen opposite on 22nd of December. 22nd of December, you will have perpetual daylight on the south pole, whereas perpetual darkness on the north pole because of the axial tilt and the orientation of Earth with respect to the sun. So this was what I introduced to you all yesterday, and we also passed saw some of the regions through which this passes. I introduced you to a region called as Lapland. Okay, so today I will be continuing my discussions from here on. So before I move forward to the discussion of the countries through which equator passes, the countries through which the tropics pass, I would like to highlight few of the important geophysical phenomenon with respect to the equator and with respect to the tropics. So, if I consider equator, if I consider equator, so let's draw the equator for you all. Okay, so this is our sun. consider what I'm drawing now as our Earth. Okay. Earth will be bulging at the center and flattening at the poles. So I'm drawing two positions of Earth with respect to the Sun. So I'm considering two important dates. On the left-hand side, I'm considering a date called as summer solstice. So I'm considering 21st of June. And on the right-hand side, I'm considering a date called as winter solstice. So I'm considering 22nd of December. So as you all know, on 21st of June, the northern hemisphere will be directly pointing the sun. So I'm drawing the axis of the earth with respect to the sun now. So let us assume that this is the axial tilt of the earth and this is the axial tilt of the earth. Okay, let us assume that this is our equator and this is our equator. Okay, so now if you see the position of equator with respect to the sun, you have to keep in mind two things. What two things you need to keep in mind? The position of equator with respect to the sun is fixed throughout the year. This means what? That on equator you will always have sunlight which is at 90 degree with respect to the surface of earth. So which two things you need to keep in mind? That the position of equator with respect to the sun is always fixed throughout the year, and number two, because of this the sun's rays will fall perpendicularly on the equator. So I'm showcasing you with respect to the diagram. So if I'm considering this as 21st of June, and if you see this, the incident sun rays, and if I'm considering the 22nd of December, and okay, so if you see both of these angles, okay, this angle and this angle, so this and this angle is perfectly 90 degree. Okay, this is our southern hemisphere, this is our northern hemisphere. So in spite of I'm considering the two extremes of the Earth's orbit around the Sun, because 21st of June and 22nd of December will coincide with the extremities, not the extremities per se. The aphelion and perihelion of Earth are rather in the months of July and in the months of January. So I'm considering some of the most extreme positions of the Earth with respect to the Sun. So even on 21st of June and 22nd of December, equator will receive perpendicular sunlight, and this perpendicular incidence of sunlight is constant throughout the year with respect to the sun. So because of this, what happens on equator? Because of continuous solar insolation on the equator surface, you have intense vertical convection. Vertical convection means what? That because of the perpendicular incidence of the solar energy, you will continuously have the water vapor, you will continuously have the water being evaporated, if I'm explaining in very crude terms. So equator will be characterized by what? Equator will be characterized by almost continuous vertical convection upliftment. I will be writing down these words in front of you on the board in a movement, but please understand this. Why? Because the position of equator with respect to the sun is fixed. Because of this, the sun's rays always fall perpendicularly on the equator because of the axial tilt and because of the orbit of Earth around the sun. And this results in what? This results in continuous vertical upliftment of the air because of the solar insolation. As the sun's energy will fall on the equator, it will hit up the equatorial regions, and because of this, air will always rise up from the equator. So, if I'm explaining you in a very crude diagram, so let's assume that this is the surface of the equator globally. let's assume that this is the surface of equator globally. The position of this surface, okay, okay, the position of this surface, the position of this surface is fixed with respect to sun, is fixed with respect to the sun, and the sun's rays will always fall perpendicularly on this surface. The angle of incidence will always be 90 degree. So because of this, what will happen? You will have continuous vertical upliftment of air due to thermal convection. So equatorial regions, so equatorial regions will have what? Equatorial regions will be characterized by what? Continuous vertical vertical upliftment upliftment of air of air. And mind you, this will be because of thermal properties. Okay, continuous vertical thermal upliftment. Why? Because the sun's rays are always falling at a perpendicular angle with respect to the equator. Hence equatorial regions will always be characterized by continuous vertical upliftment. Because of this, what will happen? Because of this continuous vertical upliftment, the equatorial regions will have will have cloud cover, will have cloud cover throughout the year, will have cloud cover throughout the year, throughout the year. And mind you, this cloud cover will be very thick. This cloud cover will be very thick because of continuous vertical upliftment of air, because of continuous vertical convection, and this will result into the formation of a cloud called as cumulonimbus. Cumulonimbus cloud. Okay, cumulonimbus cloud is a very big cloud. It will extend for the entire height of the troposphere per se. We are not going to technical details. Just remember the name of the cloud. It is called as cumulonimbus cloud. Cumulonimbus cloud is a cloud with a great vertical extent, and hence, so this is the first feature of the equatorial regions. The second feature, and hence, because of this, what will happen? You will have continuous downpour. You will have continuous downpour. Okay, you will have continuous downpour or rainfall or rainfall on the equatorial regions. You will have continuous downfall or rainfall on the equatorial regions. So if anyone asks you, can you please define the equatorial regions for us? So your answer should be that the position of the equatorial regions with respect to the sun is fixed throughout the year, 365 days, 24/7. Because of this, the sun's rays are falling perpendicularly on the equator throughout the year. And because of this, you are having continuous vertical upliftment of air due to thermal convection. And because of this, you will have continuous cloud cover over the equator throughout the year. And mind you, this cloud cover will be very thick, and the name of the cloud, it is called as cumulonimbus. Cumulonimbus clouds are clouds with a great vertical extent, and they also stretch for nearly like many kilometers too, but their vertical extent is very high. Okay, and because of this, you will have continuous downpour or rainfall on the equator. Hence, guys, this is the most important thing that I'll be discussing, and I'm writing it in red. Hence, hence, the equatorial regions, hence, the equatorial regions equatorial regions will receive number one, rainfall throughout the year, throughout the year, throughout the year, and this rainfall will be very, very intense. This rainfall will be very, very intense, and the equatorial regions will be some of the wettest regions of the world. Therefore, equatorial regions will be some of the wettest regions of the world. Some of the wettest regions of the world of the world, and this will result into what? This will result into number two. This will result into what? This will result, or this will conclude as the equatorial regions being characterized by evergreen, dense evergreen, dense evergreen, equatorial, equatorial rainforests. Okay, dense equatorial rainforests. Please mind you guys, this is very, very important info. The equatorial regions will be characterized by what? They will be characterized by dense evergreen equatorial rainforests. So anywhere you go on the equator, you will always find what? Dense equatorial evergreen rainforest. Why the term evergreen? Because the rainfall is continuous throughout the year. Okay. And why it is continuous? Because the position of equator with respect to the sun is fixed, and hence because of this you are having continuous vertical upliftment of air due to thermal convection cells, and because of this you will have a very dense forest cover on the equator anywhere on the world. Okay, mind you guys, I'm talking anywhere in the world. So the equatorial regions will always be characterized by what? Dense evergreen equatorial rainforests. Okay, I will go on explaining the characteristics of this forest too in a bit, but for now, just remember this. Anywhere on the equator you go, you will always find what? Dense tree cover. Okay, so if you open up your atlas and if you see the equatorial regions, it will be marked in dark green, indicating what? That the vegetation over here is very dense. Why? Because you are having continuous downpour. So now I will be discussing two or three very important things with regards to the characteristics of equatorial regions, the vegetation and the typical day on the equator, from wherein UPSC normally tends to ask you the questions. Okay, so let's move ahead, guys. So now I have discussed that equatorial regions will be characterized by rainfall. So let us now move ahead with the weather and climate of the equatorial regions too. So as I told you that the equatorial regions will be characterized by thick cloud cover. So but naturally the climate of the equatorial regions, if I'm discussing the climate of the equatorial regions, so the climate will be number one. It will be very humid climate. Okay, why humid climate? Because the percentage water vapor concentration, the percentage water vapor proportion, will be very high, approximately 4 to 5% of the atmosphere. Okay, so around 4 to 5 percentage of the atmospheric air will be saturated by water vapor. Okay, why? Because of this intense cloud cover, so the conditions will be very humid. Okay, number two, the climatic conditions will be very wet. Why very wet? Because you have rainfall which is continuous throughout the year, throughout the year, which is continuous throughout the year. And number three, okay, the conditions will not be hot. The conditions will rather be somewhat warm conditions. Why not hot and why not warm? Okay, please understand the difference. Okay, there is a difference between hot and warm. Hot means what? The sun is shining incessantly. So if you consider the deserts are very hot, they are very dry. Whereas if you consider the equatorial regions, guys, you are having permanent cloud cover over them. And what do these clouds would do? They will reflect back the sunlight. So, equatorial regions will not be that much hot regions. You must be feeling that sun's rays are falling perpendicularly on the equator. This means that the equatorial regions will be very hot. They will be very dry. But guys, exactly opposite happens. Okay, it is man proposes, God disposes kind of thing. So the nature God says that no, in spite of you receiving the sunlight which is almost perpendicular, because of intense thick cloud cover, this cloud cover will reflect back all the sunlight from the upper regions of atmosphere itself, and hence the atmosphere or the climate will not be as warm, not be as hot. My bad, it will rather be warm. Okay, warm, but with what kind of conditions? Enervating conditions. Okay, what do you mean by enervating conditions? Enervating conditions means tiring conditions. Why tiring conditions? Because of high humidity. Why tiring conditions? Because of very high humidity. Okay, this is very, very important. Okay, so let's say if you go to a coastal city, okay, where the humidity is very high, so your body immediately starts sweating. Okay, consider you going to a coastal location in India. Let's say you are in Mumbai, you are in Goa. Okay, you are preparing for civil service examination from Goa. Okay, I don't know whether you will be able to prepare, but okay, let's assume that you are in Goa and you are preparing for civil service examination. So you will immediately start to perspire. Why? Because the outside humidity is so damn high that your body starts sweating because of osmosis. Okay, so hence the equatorial regions will be characterized by humid, warm, enervating conditions. Hence, living in equatorial regions is not that easy. Okay, because you will continuously sweat. Okay, a positive side for this, that as you will sweat, your body will get detoxified, your skin will become somewhat glowish. So if you see the people of the equatorial regions, except Africa per se, because of genetics, their skin is not that light. But if you go to the Southeast in Asia, if you go to Central Mexico, if you go to South America, so the people over there tend to have very good healthy skin. Why? Because it sweats a lot. So your skin health is maintained in a sweaty environment. Otherwise, if your skin pores get blocked, your skin is not able to breathe, then it is a harbinger for diseases per se. Okay. So jokes aside, let's move forward. So please remember this, guys. Climate wise, equatorial region will be like this. So if I'm considering a day on equator, if I'm considering a day on equator, so how will be a day on equator? I'm reiterating. How will be a day on equator? So I'm starting my day by approximately 6 a.m. So from 6 a.m. to around 12 p.m. 6 a.m. to 12 p.m. humidity will increase. Humidity will start increasing. Okay. Humidity will start increasing. Okay. The cloud cover, the cloud cover will also start increasing. Okay. From 12 p.m. to 4 p.m. Okay. From 12 p.m. to 4 p.m. conditions conditions for thunderstorm rainfall. Okay. For thunderstorm or conventional rainfall or convectional rainfall will develop. Convectional rainfall will develop will develop. Okay, from 4 p.m. to roughly 10 p.m. Okay, you will have very very heavy rainfall. You will have very very heavy rainfall. You will have very 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 heavy rainfall. and from 10 p.m. to around 6 a.m. the sky will slightly clear off. Sky will slightly slightly clear off. The sky will slightly clear off. Okay. So the best time to party on equator is from 10 p.m. to 6 a.m. So if you go to cities like Singapore, Kuala Lumpur, all of the nightlife cities in the world. Okay. Why? See, the nightlife is even linked to geography because rest of the day, if you party, you will sweat like anything and you will end up in the hospital. You will have to have a saline, you will have to have sugars. Okay. Rest of the time, you cannot party. Only in the night time you can party on the equatorial region. So this is a typical day on the equator per se. Okay. So two times the question have been asked from this area in your prelims part. So please make sure that you are very comfortable with this. If I'm giving you a very crude understanding of this, crude understanding in the sense that in the night time the sky will be clear, the humidity will be less. As soon as you have sunrise, sunrise will be between 5:45 to 6:15. As soon as the sun comes up, the humidity starts to build up. In the afternoon, the sky will get overcast with very thick clouds. In the late evening, you will have the rainfall, which will start. It will continue till night, and again the sky will clear off. So this is the cycle which is fixed, and this cycle will repeat. And mind you, this cycle will repeat 24/7, 365 days a year. 365. Let me write down in red so that you are all getting this properly. So this cycle will continue. This cycle will continue 24/7, 365 days a year. Okay, 365 days a year. Okay, please keep this in mind. So because of this, what will happen? Equatorial regions, equatorial regions, equatorial regions will have will have no seasons. Will have no seasons. Like we have in India, we have summer, we have the summer monsoon season, we have the winter season, we have the spring season. So equatorial regions will be characterized by absolutely no seasons. Okay. Please make sure you are getting this. Okay. And number two, equatorial regions will not be the hottest regions of the world. Will not be the hottest regions. Will not be the hottest regions of the world. Will not be the hottest regions of the world. Okay, so this is a typical characteristic of the equatorial climate, of the equatorial life per se. Very humid, very enervating kind of life over there. The best time to party is from 10 p.m. to 6 a.m. So good nightlife on the equatorial regions. Okay, so these are the most important characteristics of the equatorial regions, and because of this, the vegetation on the equator will be very dense. So let us move to the discussion of vegetation too. I will cover in detail the vegetation in the later sessions, but I'm just introducing you today to the equatorial vegetation. The equatorial vegetation will be number one. It will be very dense. It will be very dense. Number two, the trees will fight for sunlight. The trees will fight for sunlight. Will fight will fight for sunlight. The trees will fight for sunlight. Okay. And the trees will be mostly hardwood trees. Hardwood trees. Okay. And you can also have creepers. Okay. You can also have creepers. and dense bushes and dense bushes. Okay, dense bushes. Okay, so the hardwood trees will be very high in height, whereas the creepers and the dense bushes will cover the lower areas of the ground. So if I'm showcasing this, the vegetation of equator to you all on a, let's say, mm, image. So let's search for the image too, so that you have a working understanding. Okay, so this is how the equatorial vegetation looks like. Okay, if I'm showcasing you all, okay, so this is one of the image. Okay, see the density of the vegetation over there. Okay, so we'll compare two images simultaneously. Okay, this image will solve the purpose for you. Okay, so this is the arrangement of the vegetation in on the equator. So on the lower side, you will have the forest floor. It is called as the understory layer. So here you can have bushes. Here you can have bushes. Okay. Here you can have creepers. Here you can have creepers. Okay. The canopy layer. Okay. The canopy layer will be very thick. You will have hardwood trees. You will have hardwood trees. Okay, whereas the emergent layer, wherein you can have the trees which can compete for sunlight, these trees can reach to a great extent. Okay, so this will not be hardwood trees per se. Okay, so these trees will be those trees which will be fighting for sunlight and which can reach the uppermost layers of the forest. So canopy trees. If I'm showcasing you these trees over here, okay, so if you can see the trees over here, so these are the canopy trees. See the vertical extent. Okay, these are the hardwood trees over here, and the lowermost area over here, you will have the bushes, wherein these bushes cannot fight for the sunlight. They are only limited to over here, so their height is stunted. So, equatorial vegetation is all a fight for sunlight. Please remember this. Okay, very crude understanding of this. I have not yet introduced to the tree species. I will do it in the later session. But just remember, you will have hardwood trees, you will have bushes, you will have creepers, and the canopy cover will be very dense on the equator. So these are some of the characteristics of the equatorial vegetation per se. Okay, so these are some of the characteristics of the equatorial vegetation. Okay, and mind you, equatorial regions will never be the hottest regions of the world. Why? Because of the intense cloud cover. Okay, so before any further ado, now let us begin with the countries through which equator passes. So I'm opening up the map dimension for you all now. So I'll be opening up the political maps of those countries through which the equator passes. Your job now will be is to take down those countries in your notes and to mark the countries very properly. Okay. Before I move forward, I want each and every one of you who will be joining me in the next class to have a atlas with you. Okay. The name it in bold. It is Orient, Orient Black Swan. Orient Black Swan. Orient Black Swan. It is abbreviated as OBS. Orient Black Swan School Atlas. Okay, Orient Black Swan School Atlas, 8th edition. Okay, 8th edition. Those of you who are listening to this lecture and those of you who will be seeing this lecture, so from my next lecture, please keep this atlas handy with you so that you can have a working understanding of whatever I'm teaching you. Of course, I'll be utilizing the maps per se with you all, but please keep this atlas handy with you so that you can understand it even better when I will be marking up the countries. Okay. So please make sure that you are keeping Orient Black Swan School Atlas with you all present in all these sessions. Okay. So now let's move ahead. I am first of all discussing with you the countries through which the equator passes. So my way of teaching the countries is from west to east. I will be moving from west to east for everyone. It's your call how you remember the countries. You can remember the countries from east to west to. You can remember the countries from west to east to. Okay. My way of teaching will be from west to east. Okay. Abhay, the schedule of the classes will be from 5 to 6 only. Okay. Every day. Okay. So today I'm introducing you to the equator. Okay. The countries through which the equator passes globally and what you can expect you to find on the equator person. Okay, so I'm beginning with South America because I will be moving from west and then I will be moving towards east. So please jot down the countries through which equator passes. I'm also marking on the equator. You can have a pen and paper with you and jot down the entries. Those of you who are watching these lectures and those of you who will be joining me in a later date, please make sure that you are bringing a copy and a pen to these lectures, because just listening to these lectures, just seeing on the board will not help you in memorizing, will not help you in getting acquainted with the atlas. So please go through the atlas properly and please go through whatever I'm teaching very properly. Okay. Abhay, you don't need to go through GC Leon. That is why I'm taking these lectures. I will cover everything for you. So don't need to worry. Just bear with me. We will be covering the NCRTs, we'll be covering GC Leon too. Okay. Just trust me very blindly with regards to the coverage. Okay. So the first area through which equator passes, it's in the Pacific Ocean. You have a small island group over here, if you can see on the board. Okay, and you can also see in your atlas this island group. This is called as Galapagos. Galapagos. Okay, Galapagos is ruled by Ecuador only. So Ecuador rules Galapagos, and Galapagos is very famous. Why? Because Galapagos is where Charles Darwin gave his theory of evolution. Okay, so please make sure that you are remembering this very properly. Galapagos and Charles Darwin is very much in use because in 12th NCRT his reference is now completely omitted. So we don't know where the evolution of human beings is now going, but you should remember that equator does pass through Galapagos. Okay. After Galapagos, the equator passes through Ecuador. The name of the country itself, Ecuador, is based on equator only. Okay. After equator, it passes through Colombia. After Colombia, it passes through Brazil. So the three countries in Africa through which equator passes, you have Ecuador, you have Colombia, and you have Brazil. And Galapagos is ruled by Ecuador only, so no need to have a separate entry, but please keep this in mind. Okay, so number one, number two, and number three. So these are the countries through which the equator passes through South America. And now, if you see South America's physical map, if I'm opening up the South America's physical map for every one of you, okay, so let us open the South America's physical map too. Okay, so this is South America. This is Galapagos. Okay, this is Ecuador. This is Colombia, and this is Brazil. So if you can see this part of South America, this part of South America, you can very well see on the board itself that this part is completely green. Okay, very dark green per se on the board. Why this is dark green? Because This is where you have the rainforests of Amazon. The Amazon River, the mighty Amazon, the biggest river on earth, drains through this part. Hence, this is called as Amazon Basin. Okay, and Amazon, as you all know, Amazon rainforests are the world's biggest rainforests, and Amazon rainforests, they are called as the selvas of the world. They are called as what? Selvas of the world. Why selvas? Selvas locally mean the lungs of the world. Why lungs of the world? Because the Amazon rainforest, they pump roughly 17% of world's oxygen. They pump roughly 17% of the world's oxygen. They pump roughly 17% of the world's oxygen. And why do you have rainforest? I've already explained, because the equatorial regions will be those regions where you will have incessant rainfall throughout the year. Hence, because of this, you have the world's biggest rainforest in South America called as the selvas. Selvas, the local name of the Amazon rainforests. But here comes a catch. This is very important. Please listen to me very properly. A current affairs discussion. Okay. The Amazon, in spite of being the world's lungs, right now they have become net carbon emitters. Right now, the Amazon rainforest has become net carbon emitter. Okay. Why this has become net carbon emitter? This you will do as a homework. Okay, I will of course be discussing tomorrow that why Amazon rainforest has become net carbon emitter. But I think that it is your responsibility too, and you should reciprocate me through, even if I'm doing this. So please see today that why Amazon rainforest has now become net carbon emitter. And the answer is very simple. It is linked to lifestyle of the human beings, and this has resulted into even more global warming and climate change per se. So tomorrow I'll be discussing why we have the Amazon rainforest as the net carbon emitter. Okay, so please make sure that you are comfortable with this info, that the regions through which the equator passes through South America, it is called as the Amazon basin. The mighty Amazon drains through this region. Amazon is the world's biggest river. The Amazon rainforest, they are also called as the selvas of the world. They pump roughly 17% of the world's oxygen. But now, because of anthropogenic activities, which I will be highlighting you all tomorrow, Amazon has now become a net carbon emitter. And this is very, very bad for the entire humanity. Okay. So now let's move forward to the discussion of the African countries, and the rest of the Africa, the Congo Basin, I'll be highlighting you all tomorrow. Okay. So now let's begin with the discussion of the countries through which equator passes through Africa. Okay. So the first country through which equator passes through Africa is a very small island country. This is a very small island country. This country is called as, if I'm zooming in, okay, if I'm zooming in, so this is a very small country. This is called as Sao Tome and Principe. Sao Tome and Principe. Okay. Please make sure that you are getting this name properly. Okay. Sao Tome and Principe. Abhay, you are right that Amazon is experiencing forest fires, but why? That is the main reason. Okay, so we will discuss it tomorrow. Don't worry. Okay, so Tau Tope and Principe. The second country through which equator passes through Africa. So this is number one. This is number two, Gabon. Number three, you have the Republic of Congo. Number four, you have the Democratic Republic of Congo. Number five, you have Uganda. Number six, you have Kenya. And number seven, you have Somalia. And you have one very important water body in Equatorial Africa. You have Lake Victoria. You have Lake Victoria. Lake Victoria is the source of one of the head streams of Nile, the White Nile. Okay, so Lake Victoria is also on the equatorial regions of Africa. So these are the countries through which the equator passes through Africa. Okay, Sao Tome and Principe, you have Gabon. Number three, you have the Republic of Congo. Then you have the Democratic Republic of Congo. You have Uganda. You have Kenya. And lastly, you have Somalia. Okay, so these are the countries through which equator passes through Africa. After this, equator enters into the Indian Ocean region. Okay, I will be discussing the Congo part. I will be discussing the physical aspects of this in tomorrow's lecture. I'm now quickly doing with the countries through which equator passes. Okay, after moving out of Africa, the equator enters into the Indian Ocean. Okay, so after coming out of Africa, equator enters into Indian Ocean, and equator passes through a country called as Maldives. After Maldives, the equator cuts across Indonesia. So Indonesia is where you have the island of Java and Sumatra. You have four major islands of Indonesia. You have Java, Sumatra, you have island of Bali and Lombok. And recently, Indonesia has also shifted its capital to a island called as Borneo. So again, a home assignment for you, which is the new capital of Indonesia. So after Maldives, it passes through Indonesia. It passes through the island of Borneo. Okay, this is the island of Borneo. So if I'm zooming in on this island, okay, so this is the island of Borneo for you all. Okay, island of Borneo has three countries. You have Indonesia, you have Malaysia, and you have Brunei. Okay, but equator does not pass through Malaysia and Brunei. Equator will only pass through Indonesia, and after that, equator enters into Oceania. And in Oceania, it passes through one of the most important countries of the Polynesian group. I'm again reiterating, it passes through Maldives, it passes through Indonesia, it does pass through the island of Borneo, but it does not pass through Malaysia and Brunei. After that, it enters into Oceania, and in Oceanic Islands, it passes through one important country of the Polynesian group. Okay, and the name of the country is Kiribati. Okay, the name of the country is Kiribati. Okay, the name of the country is Kiribati. If you can see over here, these are our oceanic island countries. So the name of the country is Kiribati. Okay. So please make sure that you are doing this too. Okay. So these are our oceanic island countries. You have three island groups. You have Micronesia, Melanesia, and Polynesia. So Kiribati is among the Polynesian group. So it also passes through Kiribati. So these are some of the countries through which equator passes. So as I said that in every lecture, first of all, I will quickly revise whatever we did in the previous lecture, and then we will continue from the part of the present day's lecture. Okay. So yesterday I introduced you to the equatorial regions per se. So four to five things you need to keep in mind when we are discussing the equatorial regions. So number first, the position of the equator with respect to the sun is fixed. It's unchanging. Okay. Why? Because of the axial tilt of the earth per se, because of the fixed orbital plane of the earth per se, and because of the unchanging position of the sun with respect to the earth. So it's like that equatorial regions are always exposed to the sun 12 hours a day, 365 days a year. So on equator, what you will have on the surface is intense vertical insolation of the sun. So because of this intense vertical insolation, the surface of the equator will experience intense vertical thermal air upliftment. Air will always keep on vaporizing on the equator because of the sun's rays falling perpendicularly on the equator. So because of this, now two things will happen. As the air is rising, as there is thermal upliftment of the air, you will have intense cloud formation on the equator. And as I told you, the clouds that form on the equator, those are called as cumulonimbus clouds. Okay, cumulonimbus clouds are those clouds which have great vertical extent and they also stretch in the atmosphere. So you have a great vertical extent and they are stretching on the horizontal extent. So because of this, what happens? That these clouds reflect the sunlight which is incident on them. So because of this, equatorial regions are taught the world's hottest regions. Mind you, don't get confused with regards to this. See, geography as a discipline is all about conceptual clarity. Okay, so if you understand this, why equatorial regions are not the world's hottest regions? Why? Because of cumulonimbus cloud formation, which reflect the sunlight there and there itself in the upper reaches of atmosphere. The technical term for that is albedo. I have not yet discussed that term, but in due course of time, I will be enlightening you with regards to albedo. For now, just remember that these clouds they will reflect the sunlight then and there itself. So equatorial regions will not be the hottest, and because of this, because of heavy cloud formation, you will have some of the heaviest downpour anywhere on the earth. So if you are standing on the equator, you will always have to carry an umbrella because you never know when the downpour will come. And because of this, the equatorial regions are characterized by dense evergreen rainforests. So it's like the more the water you put, the more you will have vegetation. It's just like the more you put in your brain good things, the more you become enlightened. So just compare good things in your brain as compared to the vegetation. So the more you put in your brain good things, the more you become enlightened. Similarly is the thing on equator. So as equator is getting good amount of rainfall, you have good sunlight. So but naturally the vegetation on the equator is going to be very dense and you have dense evergreen equatorial rainforests. Okay, so everywhere you go on the equator, you will have rainforest primarily. And because of this, the vegetation that you find on the equator is rather having very, very dense canopy. So on the surface level, you will have bushes, you will have creepers, we will keep on fighting for sunlight. And as you move above, you will have some hardwood trees and some very tall trees which try to grasp for the sunlight which is incident even at a higher height. So the canopy of the vegetation on the equator will be very, very dense. I even showcased you the images. So while discussing yesterday, I discussed with you few things with regards to the Amazon rainforest. I gave you certain assignment with regards to Amazon rainforest. So as I promised that I will be delivering that to you in present lecture. So I'm also discussing that. So I gave you an assignment as to why the Amazon rainforest, okay, Amazon rainforest being the world's biggest rainforest, they are locally called as selvas. Selvas basically means the lungs of the world. Okay, why? Because they pump together 17% of the world's oxygen. Today, the Amazon rainforest has become net carbon emitter. Has become net carbon emitter. Okay, CO2. Why so? Why so? Okay. So there are three reasons for this, which can be directly asked in mains per se, and also you can have something with regards to prelims too. Okay. So why the Amazon rainforest has now become the net carbon emitter? So the first reason for this is increased deforestation. Is increased deforestation. Okay. This increased deforestation is because of two things. Number A and number B. Number A is because of changing dietary preferences. Changing dietary preferences. Why changing dietary preferences? So as dietary preference change, you consume more and more beef, so you require pasture lands. So you require what? You require pasture lands, and because of this, the Amazon rainforests are increasingly cleared. So the more you export, the more you do animal ranching, cattle ranching, the more you will require pasture lands. And this is one of the primary reasons why the Amazon is witnessing deforestation. Okay. The second reason why Amazon is witnessing deforestation is because of local infrastructure, local infrastructure impetus. See, The Amazon rainforests are some of the most inaccessible rainforests in the world. So now the government there locally is trying to do, because of what? Because of local infrastructure impetus, the government is trying to clear the land, and hence this is the second most important reason that why Amazon is experiencing deforestation. Okay, the second reason why Amazon is now becoming net carbon emitter, this is because, very important thing, please understand, this is because of forest fires. Okay, forest fires. So some of the forest fires are natural. Okay, they are the natural way of rejuvenating of the nature, but some of the forest fires are deliberate. Okay, and if you see the data of past 3 to 4 years of the Amazon forest fires, a very sad thing comes into play, that majority of the forest fires that are being incident in Amazon, they are all deliberately been lit off. Why? Because to clear the land for deforestation and for infrastructure and also for timber industry. See, the Amazon rainforest have some of the best hardwood trees in the world. So the rich people in Europe, the rich people in North America, they require that wood for building up their houses. So the luxury of the Westerners is coming at the ecological cost of the Amazon. So this is the second reason why the Amazon is now becoming net carbon emitter. Yes, Abhay, you are pointing at good. Okay, good evening. The third reason why Amazon has now become net carbon emitter, this is again very, very important. Okay, why? Because the you have increased pressure on the Amazon's ecological resources. What do you mean by this? Increased pressure. Okay, increased pressure on local ecology. Increased pressure on local ecology. Okay, this is little bit technical, guys. So I will just enlighten you with regards to this. What do you mean by increased local pressure on ecology? Okay, so now just imagine that you have land. Say this is land A. On land A, you are having approximately 100 trees. Okay. And each of this tree can sequestrate one equivalent of CO2. So 100 trees can now sequestrate 100 equivalents of carbon dioxide. Now just assume that instead of 100 trees, now you have a land B which is having only 50 trees, which is now having only 50 trees. So and the atmospheric carbon dioxide which is being pumped is still 100. Okay, you have to still sequestrate 100 CO2. Can 50 trees sequestrate 100 CO2? The answer is yes, but it will require more what? It will require more time. So what is happening on the local ecology? You are having increased pressure with regards to, with regards to, with regards to, with regards to carbon sequestration. This is very important, guys. Please understand this very, very properly. With regards to carbon sequestration. Okay. This means what? There is a mismatch between demand and the supply, if I'm talking in purely economic terms. So the carbon which is being pumped, it is beyond the sequestration capacity of the local ecology. So, because of this, the local ecology is not able to support the increased amount of CO2 that is present over there. So, these three are the main reasons why Amazon has now become the net carbon emitter instead of net sequestering agent. Okay, so this can be directly asked in mains, this can also come in prelims. So, hence, I thought that this is an important issue which you and me need to be highlighted. Okay, another very important issue, guys, which is not yet talked. Okay, deforestation. Okay, I will discuss this when I'll be discussing Africa now. So another important issue is clearing of land for cocoa pod cultivation and for palm oil cultivation. This I will discuss when I will discussing Africa and the Malaysian regions too. So you can also add the third reason for deforestation in number one as increased pressure for cocoa pod cultivation and palm oil cultivation. This is a very dire situation, guys, but we need to work upon this. Okay. Recently, the government of Brazil has changed, the prime minister has changed. So let's hope that the things go in a positive way and we have Amazon being termed again the selvas of the world. Okay. So now, before further ado, let's move with the discussion of the equatorial regions of Africa and the Indonesia too. Okay. So just let me open up the map again. Okay. So now I'm opening up the map of Africa for you all. So the equator passes through Africa through its central part like this. This is the path of equator. Okay. Over here, you have the Central African Equatorial Rainforest. They are called as the rainforests of Congo. Okay, the Congo rainforests are very much in news for two reasons particularly. Number one, the Congo rainforests are very much in news for viruses. Okay, the deadliest viruses known to mankind, they come from this part of the world. So the deadliest virus known to mankind is Marburg virus. It comes from here. The other deadliest virus, they include the virus of Zaire Ebola. Okay, very deadly disease. You have viruses like malaria. Okay, so the malaria which occurs in Africa is very different from the malaria which occurs in the Indian subcontinental region. You have different vaccination programs too. So the Congo rainforest is very much in news for viruses. And right now, as of 2022 and 2023, the Congo rainforest is very much in news by because for the first time the government of Democratic Republic of Congo has opened up the Congo rainforest for coal mining. For coal mining. Okay. Why coal mining? Because you all know that above in Europe you have war between Russia and Ukraine, and Europe is heavily dependent on Russian natural gas for this. So, as Russian natural gas is now coming in a dwindled quantity, so the European countries are now reverting back to African countries for coal. Okay, because you need to warm up in the winters. European countries, they suffer immensely in the winter. They need to warm themselves. So now they are looting again the African continent for coal. So this is the hypocrisy, guys. On one end, you say that you are going green, and on the other end, you start again utilizing the African resources for your own comfort. And Africa, as you all know, it's not a rich continent, it's a poor continent, guys. So if money is coming, people will always welcome money first. They will not think of climate change, they will not think of ecological consequences. So the Congo rainforests are very much in news for the opening up for coal mining. And there is a national park over here. Please remember the name of the national park. The name of the national park is Virunga National Park. Okay, Virunga National Park. It is known for chimps. Okay, it is known for orangutans. It is known for orangutans. So all of these species, ape species, are now witnessing increasing threat because of the opening up of Congo rainforest for the um, coal sector with regards to the thermal power plant generation in Europe per se. So the luxury in one continent is coming at an ecological cost in another continent. Just a point to ponder, guys, where our humanity is being taken, where we are just utilizing the environment for our own gains, and we are not thinking of the outside world for even for a second. Okay, so let's move ahead. So this was the discussion with regards to the African region of Congo. Now if you come to this part, okay, though this part does not fall in the equatorial region per se, but it does have equatorial characteristics. So here you have the rainforests of a country called as Nigeria. Okay, Nigeria is known in the world as the number one country for cocoa, cocoa pod cultivation. Okay, cocoa pod cultivation. So the Cadbury, okay, the famous dialogue, like you should have something sweet after you have dinner. So one company in the world regulates the entire cocoa pod cultivation and its pricing. Okay, cultivation in the sense that cultivation is done by local farmers, but its import, its export, all of it is managed by just one single company. I will not name the company. You all know what controversies you have, this being an online medium. So An average cocoa pod farmer in Nigeria does not even earn $1 a day. Okay. And the chocolate which is being sold in the luxury markets of Europe, like Belgium, okay. So the chocolate sells for hundreds of dollars. So you just imagine that you are paying hundreds of dollars for, let's say, 10 gram or 100 gram of chocolate, whereas the farmer who is cultivating that is getting less than $1. Okay. And the equatorial rainforests of Nigeria are again witnessing increasing threat because of the increased demand of cocoa pod cultivation. Okay, so this is a very dire kind of situation with regards to the equatorial rainforest. Even in the Amazon, even in Africa, they are facing increased anthropogenic pressure. Okay, this is all with regards to the human activities, human luxury. Okay, I would like to quote Mahatma Gandhi over here that there is nature has everything for man's need, but nature has nothing for man's greed. Okay, so this is pure greed per se. Now let's move to the discussion of the rainforests of the Indonesia too. Yesterday I introduced you that you have equator passing through Indonesia, and I introduced you to an island called as Borneo, where you have three countries. You have Indonesia, Malaysia, and Brunei. And the rainforests of Borneo are some of the best rainforests of the world, and even those are facing now increasing threat. So now let's move to the discussion of the the Indonesian rainforests. Okay. So if I take you to Indonesia, so this is the island of Borneo. So this is the island of Borneo in Indonesia. Okay. So this has some of the best rainforests of the world, rainforests of the world, of the world. But even this is facing increasing threat because of two things. Okay. Number first, number first is, and this is the most deadliest kind of threat that any rainforest is facing. It is because of palm pod or palm oil cultivation. Okay, palm oil cultivation. Okay, why so? Okay, so I know that those of you who are listening to me, and including me, I won't let myself outside the purview of this, including me, guys. We all have been to big fast food chains like McDonald's, like KFC, like Burger King, like Domino's. Okay, have you ever wondered in which oil do they fry those things? Okay, everything is fried today. Most of us, what you eat, we eat all fried fruits. So, do you know in which oil do they fry? They always fry in palm oil. And palm pod cultivation is rampant on the islands of Borneo. Even Indian government has opened up the northeast for palm pod cultivation. And palm pod is a invasive species. It's a invasive species. Invasive species means what? It wipes out the local vegetation in that area. Okay. So once you start cultivating palm pod, it spreads like anything and it destroys the local ecology like anything. Okay. So it's basically my demand, your demand for increasing fast foods, for increasing fried foods, which is resulting into the destruction of equatorial rainforests of Borneo. And because of this, orangutans over here, because of this, the ape species over here are witnessing increasing threat. And the second reason for the destruction of over here is because of rubber cultivation, rubber plants. Okay, rubber plantations. Okay, you all know that rubber is very useful in transport sector, and in today's era, transport sector is dominating everywhere. So the rainforests of Indonesia, and dare I say the rainforests of Malaysia, they are also being cleared for rubber plantations. Okay, so these are the two main reasons why the equatorial rainforests of Borneo or Indonesia are being cleared. So if I tend to paint a global picture, guys, the equatorial rainforests are now witnessing increasing anthropogenic threat. They are witnessing increasing anthropogenic hazard, and this is all because of changing lifestyle patterns. Okay, if you adopt to sustainable ways, the equatorial rainforest can still be conserved. And this does not mean, guys, that the picture is entirely grim. Okay, the local indigenous communities everywhere are now advocating for this. Even the people of the local countries, the local people over there are now getting in consonance with the local tribes, and they are doing something to preserve the rainforest. So the picture is not completely grim. The only thing is these issues need to be highlighted. These issues need to be highly vocal. Okay, and it's your and my responsibility now, those who are watching me or those who will watch me, that we need to advocate for this. Okay, so we need to see always a silver lining even in the darkest of clouds. That is what I want to say. So this sums up our discussion of the equatorial regions. Now let us move towards the discussion of the tropical regions for now. Okay. So before I introduce you to tropical regions, I need to introduce you to some of the concepts with regards to the tropical areas. So first I'm introducing you to the concepts and then we'll mark up the regions on the atlas. Okay. Let's move forward. So now we are moving towards the discussion of the tropical areas. Okay, the tropical areas. Okay, tropical areas means what? The areas sandwiched between 23 and half degrees north and the 23 and half degrees south. Okay, so between Tropic of Cancer and Tropic of Capricorn. Okay, so in order to understand these areas, you first need to understand the pressure conditions over here, the pressure belts in this region. Okay, so I'm introducing you to a concept called as pressure belts. Very crude understanding, but we will not move into the advanced concepts, but relatively smaller concepts. Okay, so you all know that Earth is rotating on its axis from west to east. So if I'm considering the rotation of Earth's axis from west to east, the rotation is a circular motion. Okay. So the Earth is rotating on its axis from west to east like this. Okay. Hence you have sunrise in the east and sunset on the west. So this being a circular motion, there is a force that acts on all the bodies on Earth, and that force is valid only for horizontal movement. That force is not valid for vertical movement. Okay. I'm again reiterating. As the Earth is rotating on its axis from west to east, and you have a circular motion of Earth, so because of this, an apparent force acts on all the bodies on Earth, and that is only valid for horizontal movement, that is not valid for vertical movement. And the name of the force, it is called as Coriolis force. What is the name of the force? It is called as Coriolis force. Okay. Why does this force act? Why does this force act? This force acts because the earth is rotating. The earth is rotating. The earth is rotating on its axis from west to east. And number two, as the earth rotates, you have apparent deflection. You have apparent deflection. You have apparent deflection in the moving bodies, in the moving bodies, in the moving bodies. But this deflection or this apparent force is only valid for horizontal motion. Is only valid for horizontal motion, whereas this is not valid for vertical motion. This is not at all valid for vertical motion. What do you mean by this, guys? Okay, what do you mean by this? So let us discuss in detail per se. So as the Earth is rotating on its axis from west to east, you have an apparent force that acts on all the moving bodies. This force is called as Coriolis force, and this force produces apparent deflection. And this is only valid for horizontal motion, not for the vertical motion. So, what do you mean exactly by this? Okay, so please understand now very, very properly. Okay, if you get this concept here, you will be taken care of for the rest of the geographical discourse. Okay. So if I'm considering the Earth per se, and I'm drawing the Earth on a bigger scale, okay. So let's say this is our equator, Okay, so let's say this is our equator. Okay, and these are our polar regions. Okay, these are our polar regions. So now, if you are throwing a ball from the equator towards the poles, if you throw a ball from equator towards the poles, what you see that as you move from equator towards the poles, the radial distance of the surface of Earth from its center, it starts to decrease. So if I'm naming this A, I'm naming this B, I'm naming this C, and I'm naming as D. So if I compare these distances, A is more than B is more than C is more than D. So the distance of the Earth's surface from the center, it's becoming less and less. So from the central radial axis, the distance is becoming less. And mind you, we are throwing something on Earth, Earth being circular, Earth being spherical, the motion also is going to be circular. So just imagine that you are throwing a ball from over here to here. Now, the ball or the object needs to maintain its angular momentum, the motion being circular. And the formula of angular momentum is given by V equals omega R. Okay, where V is the radial velocity, omega is the angular velocity or the angular momentum, and r is the radial distance. So now consider the motion of this ball. Okay. The velocity with which you are throwing the ball is dependent on how fast you are throwing the ball. Can the ball change its own velocity? No. The velocity of ball. So just imagine me as the equator and you as the poles per se. Okay, so I'm throwing a ball from my end to your end. So ball is coming from my end and it is slowly coming towards you. So the speed with which the ball will come towards you, it will be dependent on how fast I have thrown the ball. Okay. So if I'm throwing the ball with more speed, it will come towards you with a more speed. If I'm throwing the ball with a less speed, it will come towards you gradually. So velocity of the ball is not dependent on the ball itself. It is dependent upon the force. Okay, now the motion being circular, the ball needs to conserve its angular momentum. So now what is happening as the ball is moving from over here to here, the radial distance from the center of Earth is decreasing. So now for the ball to conserve its angular momentum, it needs to do what? It can either increase its velocity or it needs to maintain its radial distance. Can the ball increase its velocity? Of course not. The only option which is remaining with the ball is to start deflecting, is to start meandering, or to start increasing its radial distance. So, to conserve the angular momentum, the ball will do what? The ball will start, instead of going straight, the ball will start deflecting so as to conserve its angular momentum like this. So this is the deflection which is produced because of Coriolis force. Why this Coriolis force? Because the Earth is rotating on its axis from west to east. So mind you, the Coriolis force is a apparent force. Okay, the discussion that I am making with you all, the Coriolis force is a apparent force. It's not an actual force. Why this force is apparent? Because the earth is rotating on its axis from west to east. Okay, so this being an apparent force, it tends to start deflecting the bodies. Why deflecting the bodies? The answer you got, because of the tendency to conserve their angular momentum. And as you move from equator towards the poles, the deflection will increase. Okay, so the Coriolis force of deflection is minimum at the equator and it is maximum at the poles. Why this is so? This is a higher level discussion, but for now, just remember that the Coriolis force deflection is more as we move from equator towards the poles. So if I'm summarizing the Coriolis force for you all, okay, if I'm summarizing the Coriolis force for you all. Okay, so just remember this four things. Okay, so Coriolis force number one is a apparent force. Why apparent force? Because it's not actual. It only comes in apparency because of what? Because of the rotation of Earth. Because of the rotation of Earth. Okay. Coriolis force causes what? It causes deflection. It causes deflection in the moving bodies, in the moving bodies, in the moving bodies, in the moving bodies, but only for which kind of motion? Horizontal motion. Only when horizontal motion. Okay. And in which direction this deflection is? The deflection is towards right in the northern hemisphere, is towards right in the northern hemisphere, and this deflection is towards left in the southern hemisphere. Is towards left in the southern hemisphere. Why this is so? It's a high level discussion, but for now, just remember that deflection is towards right in the northern hemisphere and towards left in the southern hemisphere. And why this deflection? Because of the tendency to conserve, to conserve, tendency to conserve angular momentum. The tendency to conserve angular momentum. Please remember this, guys, very well because of the tendency to conserve the angular momentum. And lastly, the fourth point which you all need to remember is that the Coriolis force increases. Coriolis force increases as we move away from the equator towards poles. So the Coriolis force increases polewards. So there's four things you need to remember with regards to the Coriolis force. I'm again reiterating, Coriolis force is an apparent force. It comes into play because of the rotation of the Earth on its axis from west to east. Number two, the deflection force, the Coriolis force causes deflection in the moving bodies, and this deflection is only valid for horizontal movements, not for vertical movements. Then number three, this deflection is towards the right in the northern hemisphere and towards left in the southern hemisphere. And lastly, this deflection increases polewards. So if I'm painting a picture for you all, how is this? So I know most of you must be brushing teeth. I'm deliberately saying most. I hope that every one of you brushes teeth in the morning. So those of you who don't brush their teeth, you can go to the equatorial rainforests of Amazon for your life. But those of you who brush their teeth, you must be seeing that in the basin, when you spill out the water in the basin will always circle towards right in the northern hemisphere and it will go in the sink. So just do this experiment in the morning. You turn on the tap and see in which direction the water swirls and goes down in the sink. So if you are in the northern hemisphere, the water will always swirl in the right side and go down in the sink. Whereas in the southern hemisphere, the water will always swirl in the left and go down in the sink. So a very interesting application of the Coriolis force in your day-to-day life. So please remember this. Now you must be wondering, sir, why are you teaching all this? Okay, this is needed for understanding the tropical regions. So I hope this much is comfortable, this much is sufficient for your all understanding. So now let's carry on our discussions further. So now if I'm imagining the earth per se, please focus on the board. This is again highly important. So if I'm considering the earth, okay, okay. And if I'm imagining the sun's rays that are incident on the earth, okay. So just imagine that these are the sun's rays. On the equator, the sun's rays will fall perpendicularly. Okay, these are our sun's rays that are falling on the equator. So because of this, on equator, you are having intense vertical convection. Okay, so the air will rise up above equator and the air will diverge towards the poles. Now, ideally, the air should diverge towards the poles and sink at the poles. But now, what is happening? You are having Coriolis force that is acting on the horizontal motion. So, as soon as this air rises and it starts to diverge at the towards the poles being colder, what happens? So as soon as the air rises, it starts deflecting towards the poles. Which force comes into play? The Coriolis force. Because Coriolis force is valid for what? It is valid for horizontal movement. It is not valid for this vertical movement. Mind you, this is why. This is because of the intense insolation on the equator. Okay, intense vertical insolation. Okay, because of intense vertical insolation, you are having intense vertical thermal upliftment on the equator. You are having intense vertical thermal upliftment. So Coriolis force has nothing to do with this. Okay. Coriolis force has got nothing to do with this. Okay, with this upliftment. This has got everything to do with the incident vertical rays of the sun, which are falling at a 90 degree. So once the air is warmed up, it has reached and it has started to diverge at the poles. As soon as it starts diverging towards the poles, Coriolis force comes into play, and the air, instead of rising and diverging and sinking at the poles, the air sinks at around 30 to 35 degrees north and also 30 to 35 degrees south. 30 to 35 degrees south. So, because of this, if you consider equator, because of this, if you consider equator, on the equator, you will always have low pressure. Whereas as you move towards the tropical areas, you will have what? You will have high pressure. I'm again reiterating, because of the sinking of the air at the tropical margins or at around 30 to 35 degrees, on the equator you will have low pressure belt, whereas on the tropical areas you will have a high pressure belt. Okay, so this is called as equatorial low pressure belt. Whereas on the tropics you will have a high pressure belt at around 30 to 35 degrees north and 30 to 35 degrees south. Why this is so? Because the air, instead of rising and diverging towards the poles, it sinks at around 30 to 35 degrees both north and south. So on the tropical regions or on the subtropical regions, you will have subtropical high pressure belt. Subtropical high pressure belt. And mind you, this will be at around 30 to 35 degrees north and 30 to 35 degrees south. And this is why? This is because of what? This is because of Coriolis force. Coriolis force coming into play. This is because of Coriolis force coming into play. So, but naturally, the area sandwiched between the Tropic of Cancer and Tropic of Capricorn, you will have the conditions which are high pressure conditions. So, if you go on Tropic of Cancer and Tropic of Capricorn, naturally you have what kind of conditions? High pressure conditions. So, now coming back to our discussion of tropical areas. Coming back to our discussion of tropical areas, you will have what? Because of Coriolis impact, because of the apparent deflection of Coriolis force, air, instead of sinking towards the poles, it is sinking on the horse latitude or it is sinking on the tropical latitudes. And because of that, the tropical areas are characterized by number one, high pressure conditions. They are characterized by high pressure conditions. The simple answer, because of what? It is because of Coriolis force. Coriolis force deflection. Okay, very simple answer, plain answer. Just need to remember this for now. And because of the high pressure conditions, as the conditions are high pressure, on equator the pressure is low, so the air is rising, it is resulting into cloud formation. Now just imagine the pressure is high. Just imagine this is the tropical area. If I'm assuming this being the tropical area, this part of my hand, and the air is sinking over here, the pressure is high. Will it result into cloud formation? Definitely not. Okay, you have cloud inhibiting conditions over the tropical areas because the pressure being high. And hence, on the tropical areas, because of high pressure conditions, you don't have cloud formation. Okay. The cloud formation on the tropical areas is inhibited, is inhibited. Okay, this is very, very important, guys. Please understand this very, very properly. Okay, what do you mean by this? That because of high pressure conditions, you don't have cloud formation on the tropical areas or in the subtropical regions where the air is sinking. And as you don't have cloud formation over these areas, what happens? What happens? The sun's rays will penetrate directly. The sun's rays will penetrate directly on the tropical areas, and because of this, the tropical areas will now become the hottest regions of the world. Will now become the hottest regions of the world. Hottest regions of the world. So if someone asks you, okay, which are the hottest regions of the world? So mind you, you should not say those are the equatorial regions. You should say what? That those are the tropical regions. Why? Because of high pressure conditions, you are having inhibited cloud formation. Okay. So make sure that this is imbibed in your brain, and as tropical regions are the world's hottest regions, so the tropical areas will be characterized by what? The tropical areas will be characterized by what? They will be characterized by deserts. They will be characterized by deserts. Why? You don't have cloud formation, there is very less rainfall, and because of this, on tropical areas predominantly you will find deserts. As we discussed on the equator, what you find primarily on the equator is rainforests. On tropical areas, what you will find primarily are the tropical hot deserts. And because of this, the climate of the tropics will be hot, dry, arid, hot, dry, arid, or semi arid. As we discussed with regards to the equator, the climate of the equator is warm, wet, and humid. The climate of the tropical areas will be hot, dry, arid to semi-arid. Hot, why hot? Because the sun's rays will now fall directly on the surface. And mind you, sun has apparent migration between the northern hemisphere and the southern hemisphere, between the Tropic of Cancer and Tropic of Capricorn. So when sun will come about Tropic of Cancer, the sun's rays will be directly incident. They will be perpendicularly incident on the tropical areas in the north. So if I'm considering Sahara Desert, so sun's rays will be directly overhead on Sahara in the months of May and June. Whereas if I'm considering Australia, the Australian outback will have direct insolation reaching on it in the months of December. Okay. So the climate will be very hot. You will have temperatures exceeding more than 50 degrees Celsius. It will be very dry. Why dry? Because you don't have any rainfall. Okay. Very, very less rainfall. Dare I say, very scanty rainfall. You can have some regions in the world where the rainfall is not occurring for 5, 10 years in consecutive. And arid to semi-arid. What is arid or semi-arid condition? Arid conditions means that imagine that you are having some rainfall, the water is there and the water has now evaporating. So aridness basically means how much you have evaporative losses in any region. So if you are having very high evaporative losses, the region becomes arid to semi-arid. Otherwise, if evaporative loss is less, the water can be present over there in the form of lakes, ponds, or some reservoirs too. Whereas in deserts, you don't find anything except the oasis. So the climate of the tropical areas will be hot, dry, semi-arid kind of thing. Okay. So if I'm summarizing this for you guys, whatever we discussed today, so I introduced you to the tropical areas. Before discussion of the tropical areas, I introduced to a topic called as Coriolis force. Why we need to study Coriolis force? Because Coriolis force is integral to understanding the high pressure conditions over the tropical areas. What is Coriolis force per se? Coriolis force is an apparent force which comes in play because of the rotation of Earth on its axis from west to east, and because of this, you have apparent deflection in the moving bodies, and mind you, this deflection is only valid for horizontal movement, not for vertical movement per se. Okay, and this deflection causes the deflection in the moving bodies towards right. So your perspective, this is right. So my perspective, this is left. So right in the northern hemisphere and left in the southern hemisphere. Very interesting thing I told you. When you will brush in the morning tomorrow, see the direction in which the tap water is going into the sink. If you are residing in the northern hemisphere, the water will swirl towards right and go down. And if you are residing in the southern hemisphere, the water will swirl in the left and it will go down in the sink. Okay. Very interesting application. And hence, because of this, now what will happen? The air, instead of rising and sinking towards the poles, the air will sink at these subtropical latitudes. It will rather sink at latitudes called as horse latitudes. Why do we call them as horse latitude? A very interesting story behind it. I will discuss it tomorrow. Okay. And because of this, the tropical areas are those areas where you have high pressure conditions. We call it as subtropical high pressure belt. On equator, as you have intense vertical convection, so the equatorial areas will have low pressure, tropical areas will have high pressure. And as tropical areas have high pressure, you don't have cloud formation over those regions. You have inhibited cloud formation, and hence the tropical areas becomes the world's hottest regions, not the equatorial regions. Please clear this thing in your mind that equatorial regions are not the world's hottest regions. The tropical regions are the world's hottest regions. And hence, on tropical areas, if you go, you will always find deserts, and the climate will be hot, dry, arid to semi-arid. Okay, so this is what we discussed today. So now let's open up the map and just let me show you the dry desert topography of the tropics. Okay, very interesting to see. In the next class, we'll see the countries through which the tropics passes and the deserts through which the tropics passes. So first, I'm doing with the Tropic of Cancer per se. Okay, so I'm beginning first with the discussion of the Tropic of Cancer with regards to the Mexico region. Okay, so So if I'm zooming in over here, the Tropic of Cancer does pass through Mexico. Okay, this part of Mexico. Okay, the Tropic of Cancer does pass through this part of Mexico, and over here you have an entry called as Mexican Plateau. Okay, you have an entry called as Mexican Plateau. It is one of the driest regions of the world, and you can even see this is showcased in brown shade. Okay, light brown shade indicating that this is a dry region. If I now move forward towards Africa, the areas through which the Tropic of Cancer passes. So as soon as you will see Africa, you will see this very dry region of the world. We call it as Sahara and Sahel region. So if I'm showcasing you the region on the map, see this entry. Okay, this complete region of the world. Okay, this complete region of the world. This is Sahara, Sahel belt, and this is our Saudi Arabian peninsula. So as you can see in your atlas, the tropical regions will have deserts. Here you have Sahara Desert, and here you have the Saudi Arabian Desert, the Saudi deserts. The name of the deserts I will highlight you in tomorrow's lecture. But as I told you that the tropical areas will be having what? They will be having tropical hot deserts. So please keep this in mind, guys. Okay. And if I move towards India now, so all of you know in India we have the tropical hot desert of Thar. So in India, if you can see on the west side of Rajasthan, you will again see the dry desert of Marustali, this light brown shade. Okay, we call it as Thar. So this is our Thar desert. Okay. So the Tropic of Cancer, you have all these dark or light brown shaded areas indicating deserts. Similar thing you can expect for the southern latitudes too, where you have Tropic of Capricorn. So if I take you to the Africa, and if you see this part where I'm highlighting, so this part again, you will have tropical hot deserts. You have the tropical hot deserts of Kalahari, Namib Desert. The deserts name we will do in the next class. I will also highlight the countries through which the Tropic of Cancer, Tropic of Capricorn passes per se. So this again a very dry area. Okay. And now if I pin in Australia in this circle, okay. So if I'm opening up Australia, see how Australia is. Okay. Two-thirds of Australia, okay. Two-thirds of Australia is desert. Two-thirds of Australia is desert. It is called as the Australian outback. It is called as the Australian outback. Okay, it is called as the Australian outback. Okay, so make sure that you are imbibing this properly in your brain too, that two-thirds of Australia is desert. Okay, why so? Because the tropical areas will be the hottest regions of the world. They will be characterized by tropical hot deserts. Okay, so in the next class, we'll mark up all the entries. We'll mark up all the important parameters with regards to tropics. I hope that you are all comfortable with this info. So before ending, I'm again reiterating my name to you all. Okay, my name is Pritesh Maturkar. Okay. You can join me on a Telegram channel called as Geography by Pritesh Sir, wherein I will be keep on posting the important tidbits with regards to the geography discipline, and I'll be also posting the current affairs. And the share joining link is telegram.me underscore geography underscore PM. Mind you, there is an underscore PM, so you can use this joining link for joining this Telegram channel too. Okay. So on the behalf of StudyIQ English IS, I thank you all for attending this session. Work hard and smart because that is what is needed in civil services examination.